有请主持人。
Now let us welcome the moderator of this session, Mr. Hong Yongqing. Ladies and gentlemen, here we announce the opening of the Pujiang Forum, the Sino-Dutch Joint Innovation in Water Technology Country of Honor Sub-Forum.
Joint Innovation in Water Technology Forum.
Water is a very important and permanent topic in the integrated innovation. Worldwide, the focus on low carbon is to treat water. That's why water technology has brought about not only technological innovation, but also the innovation in models, cooperation, and how we maximize our efforts. Against the context of weakening climate change, the China-European Science and Technology Cooperation will demonstrate a new model. Without further ado, we would like to invite His Excellency Wim Berts, Ambassador of the Netherlands to China, to deliver the opening speech.
Wim Berts, Ambassador of the Netherlands to China, to make a speech. Welcome. Dear panelists, distinguished guests, ladies and gentlemen, good morning to our Dutch audience online, and 下午好 to our Chinese viewers. 我是荷兰大使和
I'm the Ambassador of the Netherlands to China.
To join you here today and to welcome you to the Sino-Dutch Joint Innovation in Water Technology Country of Honor Sub-Forum. It's great to see participants joining this forum from both the Netherlands and China, and from different types of organizations. Personally, I'm very happy that this forum takes place today as a part of the Pujiang Innovation Forum. We are very glad to have been invited as a guest country of honor to the forum. It is timely, as this year we are celebrating 50 years of diplomatic relations between China and the Netherlands at ambassadorial level. Our innovation exchange, trade, and people-to-people contacts go back way longer than 50 years. Over the decades, the relationship between our two countries has turned into the multifaceted and strong relationship that we have today. We've got much to learn from each other, and this is an important pillar in our bilateral relations. The Netherlands and China already work together on many topics. Collaboration is even more important to tackle global challenges together. This requires a partnership between governments, the business community, and science. The field of water is a good example of a challenge where it's important that we bring together the best scientific and entrepreneurial minds, and that China and the Netherlands find each other in collaboration. The world's water problems are one of the biggest ones facing the world today. For example, on water quality, water reuse, and water availability. Just look at the drought that both parts of China and the Netherlands are facing right now. The Netherlands and water are inextricably linked. A major part of our country is below sea level, and the Netherlands, like Shanghai, is a delta area where major rivers meet the sea. Years of investment in the high-quality Dutch knowledge infrastructure in the field of water have enabled the Netherlands to build a reputation as leading country in water technology innovation. The international ambition of the Netherlands is to increase the water security and water safety of more than 100 million people worldwide by 2030. And to keep our front-runner position in the field of water technology, the Netherlands established various knowledge and innovation consortia. WETSUS is an important European center of excellence for sustainable water technology. This knowledge institute is part of an innovative ecosystem that we are very proud of. I strongly believe that connecting this ecosystem to partners here in China will enable us to address important challenges that the world faces in terms of water. Before I conclude, I would like to give a very special thank you to the hosts of the Pujiang Innovation Forum, the Ministry of Science and Technology, and the Shanghai Municipal People's Government. And I would also like to thank the China Association for International Science and Technology Cooperation, CAISTC, and the China Association for the Promotion of Science and Technology and Finance, CSTF, for jointly organizing this forum with WETSUS. I sincerely hope that after this forum, you will have a better idea of how the Netherlands and China can work together in this field. And I'm very much looking forward to seeing our partnership in this area strengthened and new ideas sparked through your discussions today. Thank you very much.
Thank you very much. From Netherlands. The next speaker comes from the Ministry of the Chinese Science and Technology. 下面我们将
Next, let's give the floor to the Deputy Director General Xu Jie from the Department of International Cooperation of the Ministry of Science and Technology of China. Distinguished Ambassador and Director General Hong Hou, colleagues from China and the Netherlands, good afternoon. I'm very delighted to attend today's Sino-Dutch Joint Innovation Forum. This year marks the 50th anniversary of our diplomatic relations. We are very delighted that the Netherlands is the country of honor today, and thank you, Ambassador, for coming here in person. China and the Netherlands will host a series of events at the forum. Today's forum on water technology is one of them. I believe that through our exchange and talks, we will know more about each other and lay a solid foundation for future cooperation. President Xi Jinping has said that water is the source of civilization and ecology and survival. The UN Water Report points out that climate change has brought disasters, and 90% of them are related to water. With severe climate change, China's shortage of water and water disasters are prominent issues. European countries face a lot of floods and droughts. China and Europe all face serious water challenges. We want to remove the restraint of water on sustainable development. So we need to develop our technology and carry out a lot of water-related projects, especially some scientific challenges about water. Water technology is a matter that involves the livelihood of the two peoples. The Chinese people always think water is very important, and China has a lot of experience in hydrology. The Dutch people in the lowlands have developed a strong country, and in their relationship with water, they have their unique water treatment capabilities and technologies. In 1999, we signed an agreement on government cooperation, and we have some cooperation projects
and on industrial collaboration. Our universities, businesses have a lot of cooperation in environment areas, and we have very successful collaboration. Today's forum focuses on water. Many Chinese and Dutch panelists and government officials are present here. We hope that through today's event, we can exchange ideas and insights and introduce our development in relative areas and share our knowledge and demonstrate our technology innovations and talk about challenges and opportunities in water collaboration. I hope that on the occasion of the 50th anniversary, we can use technology innovation to cope with the challenges of water and climate change, and we can jointly work on the industrial changes brought about by carbon neutrality. I also hope that we can do some joint research and innovation so that we can go to a higher level in our collaboration. I sincerely wish the forum a complete success. Thank you. Thank you, Deputy Director General. Next, let's give the floor to the Deputy Director General of Shanghai Commission of Science and Technology, Ms. Huang Hong. Dear Ambassador, Deputy Director General Xu, and Professor Buisman, and Academician Zhang Jing'an, ladies and gentlemen, I'm very delighted to attend today's forum on water. First, I want to thank the country of honor and the ambassador for coming here in person. And thank you, Professor Buisman, for attending online, and also academician Zhang Jing'an is here with us. I also want to thank the embassy and also the consulate general and also officials overseeing innovation and technology from the Netherlands for coming here. Here on behalf of the Commission of Science and Technology, I wish to congratulate on the successful opening of the Water Forum, and I want to extend a warm welcome to all the participants.
Shanghai is known as the Oriental Pole. As a megacity on the southeast coast of China, we face challenges such as rising temperature and sea level, extreme weather events, etc. All pose serious environmental challenge to the city. As an economic hub, we put great emphasis on environmental protection, carbon emission reduction, as well as economic growth. We rely on technology to address issues such as water and the environment. The Netherlands is a hub of sea transportation and gateway to the European continent. About 2/3 of the land is around the sea level. It has worked against the odds and become an economic powerhouse in Europe in areas such as agriculture and forest. It has been very robust. It has achieved very strong economic growth, robust industry, and very intelligent use of its land and natural resources, which are very valuable to Shanghai. We should learn from the Netherlands. John's Connect promoted the establishment of the Huangpu River Bureau in Shanghai in the last century. He has been working in the city for many years to clear the water channels, waterways in Shanghai to allow smooth riverbound transportation. Even decades later, we still receive letters from the Netherlands to remind us about the lifespan of the waterway in the city. In recent years, universities in Shanghai have worked closely with colleges in the Netherlands in areas such as the scientific use of the coastline and seabound areas. All of this show that we enjoy a very solid foundation in bilateral cooperation. Against the background of low carbon development, both Shanghai and the Netherlands face new challenges in the area of water. By 2025, 2.4 to 3.3 billion people in the world will face shortage of water. 90% of climate crises are related to water. Climate change, rising sea levels pose threats to cities in countries like Shanghai and the Netherlands. Water technology is an urgent issue for both the kingdom and Shanghai, and a great opportunity for us to working together. We are keen to see business leaders and scientists in both sides work together to contribute their wisdom to better protection and utilization of water resources in the face of these emerging new and common challenges. Last but not least, I would like to wish this forum a great success and wish all of you a pleasant stay in Shanghai and successful work. Thank you. Thank you, Ms. Huang Hong. Now we'll move into the keynote speech session today. Our topic is model innovation.
Section of this section is the model innovation. 我们首先
May I invite Vetsu's founder, Professor Kais Busman, to give us a presentation. Innovation model of sustainable water technology in Europe for a fairer and a more sustainable future.
Professor Biological Recovery and Reuse Technology at Wageningen University. He is the founder of the Best Suits. Okay, welcome.
Good afternoon, Excellencies and all other people that are present today. We are very proud that we were invited to give a lecture at this very important conference in China. Water scarcity and water quality will be among the most eminent problems of humanity very soon. The Netherlands are very well known for water management. And of course, water flooding and water scarcity from a water quantity point of view is also very important. And these problems are all fired up by the climate crisis. And solving the climate crisis is a very important topic of today. In this slide, you see the amount of salt water projected beside the Earth. But beside the salt water, you see two other projections. One is for the fresh water, but that includes also the fresh water on the poles, of which is not really available. And the last dot is the fresh water that's available to mankind. And you can see that 8 billion people are dependent on a small amount of water. For oil, there are alternatives, but there is no alternative for water. Humans in weight are about 50% water, but humans in molecules are 99% water. So water technology is about the survivorship of humanity. Innovations are important, and time for water innovations to be applied in society are much longer than for innovations in computer sciences to be applied in society. But a crisis increases the adoption rate. We have done research on this, and we found that the time for adoption can be twice as fast if the innovation is needed for a crisis. And we believe that we're going to the direction of such a crisis. So the interest in water technology will increase also. The Netherlands is going to invest more than 500 million euros in water innovation in the next 10 years. With our new National Economic Growth Plan, together with all the institutes that the Netherlands already had. And WETSES will also play a very important and leading role in the water technology innovation in the Netherlands. Water technology problems are more or less the same all over the world. We all drink about the same quality of drinking water, or should drink the same quality of drinking water. We all produce the same amount of sewer water. So by working on water problems in the Netherlands, we also will have impact on a global scale, because our solutions can be applied in many other regions in the world. But maybe our endeavors are not big enough to work on this very important problem. So international cooperation is very important for solving the water problems. And therefore, we are very proud and very happy to work on the VETSIS China concept. And in this idea, our VETSIS model, which I will explain to you in a minute, will be transferred to China, and we can do it in China, of course, on a much bigger scale, because China is a much bigger country than the Netherlands. About 2 years ago, we signed an MOU with the CSTF. Unfortunately, the corona crisis came in between, and therefore the implementation was delayed. But we silently continued to work on this topic. Also, the attention of this conference might help us to bring our dream of a VETSIS China closer. Because we believe that there are common challenges. The delta of the Netherlands and the Yangtze Delta look very similar, very densely populated areas with a lot of industrial activity. So the challenges in carbon, water, and economy are similar. So we could learn from each other and we could help each other. Now we come to the chapter of VETSIS. What is VETSIS? VETSIS is an innovation institute that wants to bring together the knowledge from companies and the knowledge from universities and build on this knowledge to increase the innovation speed. At this moment, about 106 companies have joined VETSIS and 25 universities. We're working on 60 projects at the same time in 21 research teams. So although we are a relatively small institute, we are one of the most important water institutes in the world. And I'll try to explain to you how our model works. In the first place, our cooperation is based on trust. And let me first explain how we do that. We do that by dividing the program into research teams. Like I said, we had 21 research teams. A research team is also the same as an intellectual property cluster. And in such a cluster, we have about 5 to 8 companies that join such a cluster and about 2 to 3 universities. And together, they work on the common knowledge to work on innovations with PhD projects. So in this example, you see our blue energy cluster, and where we work on making electricity from freshwater and saltwater combination, mixing. And you see the 3 universities, TU Eindhoven, Wageningen University, and the University of Twente are cooperating in this. And we have achieved within 10 years that we could build the largest pilot plant in the world, making electricity from this mixing of salt and fresh water. The VETSIS Institute comprises of 21 of these research teams. And of course, this presentation is not long enough to treat them all. But here you can see a glance and the 4 main topics we work on: sustainable water, healthy environment, recovered resources, and drought resilience, and all the research clusters we have on that. And they all consist of the number of companies and the number of universities that work in a small and confined way. And in that way, we can create trust. Because if you make corporations too big, then the trust will become impossible. Trust factor is influencing innovation efficiency. And from literature, we found out there are 3 very important parts of this. First, the innovation reputation that needs to be high. And like I said, VETSIS has this reputation. Secondly, the integrity must be high. You must be reliable in what you say, and you must strive to the common good of all the partners. And thirdly, there must be a feeling by the partners of goodwill from VETSIS that we are trying to do the right thing for our partners. And these are the 3 factors VETSIS is working on to increase the trust factor of all its partners. So one of the things we do is that 3 times per year, the PhD students present the progress during the team meetings. We contractually agreed with all the partners that we will do this every year again. And with this, the professors also agreed that they will not work on the same topic as they do in the research team with companies outside the research team to increase the reliability and integrity of the research teams. In this way, we create innovation communities because trust is necessary for liberating knowledge of all the parties to speed up innovation. If all the parties keep the knowledge for themselves, the innovation will go 10 times slower. And in this way, a small institute like WETSES realizes unbelievable innovation efficiency. And we create with this innovation community a balanced focus. We have the way to include small SMEs that have very high-tech knowledge, and we create together a large critical mass. And this is important because the water sector, of course, is relatively small compared to all other sectors in the economy. But water is necessary for almost every aspect of economy. And here you can see it includes not only drinking water and sewer water, but also the health and the energy and industry and the food system and the agriculture system. So almost all aspects of economy. And they all need water technology. And by combining all these water technologies in one research program, we can indeed create this critical mass. Another thing that is essential for programs like this to create this creativity and to solve difficult problems is multidisciplinary cooperation. And in the WETSES program, we do that by bringing the PhDs of different universities in one independent lab, separate from the universities. And in this way, we connect about 50 professors to the WETSES program. And by combining the network, the insight, the knowledge, and the reputation of 50 professors in one program, WETSES in knowledge is the largest water university in the world. Of course, not in size. To give you an impression of these 50 top professors, you see some faces here. And of course, I have no time to discuss them with you, but many of them won very prestigious scholarships in Europe. And to give you an impression of the universities that are connected to WETSES, I show you the logos of these universities. And of course, the most important ones are the technical universities of the Netherlands that are the core of our network. But to increase the relevance of our program, we use the Dutch invented financing system that the companies have to pay 25%, the universities have to pay 25%, and the government pays 50% of the program. So for companies, it's not just a hobby to do research with WETSES, but it's a strategic investment. And because it's a strategic investment, we create a much more relevant research program than if it was for free. To give you an impression of the companies that join WETSES, I show you some logos of these companies. Some of them are very famous. Some of them are, of course, very small and only known in our network, but will become famous in the future. Not only research is necessary, but also an innovative ecosystem. So WETSES takes care of the science, and we all do this in Leeuwarden in one spot. Around us, we have the universities of applied sciences that can do the testing and the engineering and the scaling up of our scientific work. And finally, we have a business cluster, the biggest business cluster in the Netherlands for water technology, for companies that can do the entrepreneurship and the final implementation in society. Together, we have about 200 companies joined. Together, we can think of the market questions of the future. We can translate them in ideas for new innovations. We can then do scientific projects. And if we find something new, we can do the engineering and the testing. And if that is successful, we have an international marketing network to bring these technologies worldwide. And such an innovative ecosystem is shown over and over again is absolutely necessary for fast implementations of innovations. So this is WETSES. What's our plan for the coming 10 years? We have made a new business plan for the next 10 years, and we have decided to focus on sustainable water. And here we talk about chemical-free, natural-based water systems to take care of the slowly but certainly poisoning of humanity. We want to work on a healthy environment, and here we mean that we want to have sensors and inspections and artificial intelligence to predict if the water is safe and if the treatment is good enough. We want to work on drought resilience, of course, from a technology point of view, not only storing water, but changing the soils and the meteorological systems. Finally, we want to work on circular economy, recovered sources, because the water sector, many resources are in a very diluted form present and leave the economic zone and slowly but certainly disappear into the sea or garbage pits. So in order to recover these very diluted streams into valuable resources, that's a very important topic for WETSES. And finally, we want to use this research program to increase the competitiveness of the companies that work with us. I want to give you only a few examples of our program because it would go too far to discuss the whole program. So first, we work on source separation of toilets from sewer systems. Because the sewer systems have become so polluted by all the chemicals that we add to the sewer systems that the sewage sludge cannot be used in agricultural systems anymore safely. Therefore, by separating the toilet material, which is very clean in nature, we can produce safe nutrients for agriculture. And these vacuum toilets are very interesting because they also save, they are by far the cheapest way to save drinking water for flushing the toilets. And at the same time, can easily be adjusted to vacuum grinders in kitchens, so that also the vegetable and fruit waste can be joined to this vacuum toilets, and then we can digest this, and we could safely produce methane, and at the same time produce a product for agriculture. So we are very enthusiastic about this new technology that is tested now at several places in Europe already on a few hundred houses scale, so ready for massively implementation. Another aspect of safe drinking water is that the pipes, the drinking water pipes, are completely leak-free, because if they leak, also pollution can come into the drinking water system. In the Netherlands, we only lose 3% of our drinking water, and with that, we are one of the world champions. But still, our pipe system is about 50 to 100 years old, and which places need replacement and which places do not need replacement is the big question. We have developed a new ultrasound technology, which we can predict which pipe sections need to be replaced in the coming 10 years. And that way, we can save billions of euros pipe replacement. In the other team of drought resilience, we have started on a project which has a very high ambition of regreening the Sinai. And of course, this sounds almost unbelievable, but looking at the soils and at the humidity and finding ways to change that and use natural systems to produce enough water to grow a new forest in the Sinai, which then automatically will attract rain itself, would be an enormous benefit for society. And of course, we have the example of the Lus Plateau from China, but the Sinai desert is an even bigger challenge because there is less rain than in the Lus Plateau. WETSES works on the recovery of many resources. One of them is CO2. The recovery of CO2 from industrial streams and from the air is going to be very important in the future to reach climate neutral CO2 concentrations. WETSES works on electrochemical systems based on water technology, and we found that they can be used for CO2 recovery in a very energy efficient way. So we hope that also this technology could contribute to the future. And the final target, competitiveness. We have a very large program, which is also financed by the Dutch government, that is looking at increasing the entrepreneurship of scientists. Science that is not used is dead science. So we scout and look for spin-off companies with our PhD students and master students. We help them with intellectual property. We help them with the validation of their technologies. And we help them with networking. And finally, we also have a fund that can help fund their new innovations. And we hope in this way there will be more innovations really used in society. Then a completely different topic, that's our education program. We already start our education at the primary and secondary schools, looking for young talents that are interested in water technology. And we call this our Young Wetses department. And one of the things we organize for the entire Netherlands is the Stockholm Junior Water Prize. And the Stockholm Junior Water Prize is a very big international competition with about 50 countries, among which I believe also China. And they compete with water innovations done by young people which are younger than 18. And if you win this prize, you will be on the podium with the Crown Princess of Sweden, the future Queen Victoria. Every country has to organize its own competition to select the person that can go to the Stockholm one. And the Dutch Junior Water Prize is won already several times by Wetses. Unfortunately, the Stockholm one has not been won yet by a Dutch team. One time we became second, so we are getting close. We also organize a master degree in water technology. And at least 6 Chinese students every year join this Wetses Academy, and they are always very positive about the level of our degree. And finally, we have this unique doctoral program where you can do your PhD program in Wetses. And also here, we have every year several Chinese PhD students joining our program. So there are already many bindings between the Netherlands and China within Wetses. Another topic is completely new, and that's art. There are some philosophies that they think that art and sciences can strengthen each other. And this is something that is interesting to investigate. And it's also important to bring science closer to the public. So we have started this new program, Arts Meets Sciences, where we are looking at very interesting phenomenal things from water, which is an endless inspiration source for art, and see if it can be brought to the bigger public. Here you see an example of electrified water that has been displayed at Art Rotterdam in 2020. Here you see a demonstration unit of blue energy where we mix fresh water and salt water, and then a small windmill is starting to rotate. And it's opened by our king in 2014. Here you see an example of Vortex. This is a phenomenon very much researched in Austria, and we have a very close cooperation with Austria to research this further. All these examples show that water technology can be a big inspiration for art. And we are very proud that with the cooperation of China, there is now a fund available to work on this and bring artists and scientists together to build about 20 to 30 art objects that will be displayed in China for sure, and hopefully also in the Netherlands. So we are looking forward to that. Innovations determine the future of the world. So we must be very careful what kind of innovations are needed. And therefore at Wetses we defined coherence. We should look for coherence, that a solution for one crisis is also the solution for another crisis and not the start of a new crisis. And we have in the past, unfortunately, seen many non-coherent solutions, like PFAS, which are fluorized chemicals. And they are used almost in every aspect of our life, but now we find that they are completely what we call forever chemicals and don't break down. Therefore, the sewage sludge of our cities is not suitable for agriculture anymore. So these are non-coherent innovations. We should look for coherent innovations. That's why for Wetses it's so important to become circular and to become nature-based and chemical-free. Water connects us all. All import and export contains water or was produced with water. We are water. Water is life. Water connects. Thank you very much for your attention.
Okay, Professor Wiseman, please stay online because we have some questions. 刚才这个布凯斯
Just now, Professor Brisman gave a great presentation on water technology. Starting from 2003, in the Wageningen University, he began to work on biological recycling and the technologies. Now, he wants to use biological methods to recycle some organisms and minerals so that in industry and agriculture they can be used again. He is a professor at Wageningen University. He is also the founder of WETSUS, WETSUS. At WETSUS, he is the founder and a member of the executive board. Just now, in his presentation, a lot of our academicians were listening online, and they have a lot of questions. I've summarized these questions. They say that, Professor, you are an expert on water technology. We know that Europe is now facing drought that's unprecedented in 500 years. So in your mind, water technology innovation, what is its most urgent mission? What should we do in this context? WETSUS, most of its partners are in the Netherlands or in European universities or companies. In the future, will you consider developing partners in other areas, including China?
The Netherlands is aiming for a rapid transition to a low carbon economy, and China is set to become carbon neutral before 2060. Can you please give example of the Netherlands' innovation methods towards a greener future? Is it possible to introduce the advanced technology and application to China and to seek wide cooperation? 这个，请你在我们这个
Would you please take these questions?
Can you hear me?
Yes, we can hear you.
Fantastic. It's unbelievable, this online meeting possibilities these days. So thank you very much for the question. I would limit myself to the water sector because for the energy sector with the windmills and the solar power, I guess China is way ahead also. So this blue energy example that I gave, where a river floats into the sea, for every cubic meter per second of river water that reaches the sea, we can make a power of 1 megawatt. Also in China, many rivers go into the sea. So it would be very exciting for us to cooperate and join with China to demonstrate the blue energy technology to produce electricity completely carbon-free, and also in contrary to wind power and sun power, also continuously energy. So that would be one of the examples for carbon-free cooperation between the Netherlands and China. Does this answer your question?
Okay, thank you. Thank you for your answering. And because of the time limit, so maybe we can talk about in the future, later. We organize some other activities. And we can meet either in Netherlands or in China or online. Thank you very much. Thank you.
Thank you.
女士们、先生们，
Ladies and gentlemen, next, we would like to give the floor to
东亚科学院中国科学技术常务副主席、科技
the executive vice chairman of the
科技日报报社原社长张景安
Zhang Jing'an from the China Science Center of IEAS and the former president of Science and Technology Daily. He will talk about model innovation.
张金安
And innovation drives development. Together we build our future.
of the China Science Center of the International European Academy of the Science. And he is also the former Vice Minister of the Chinese Ministry of Science and Technology.
Distinguished guests, good afternoon. First, I wish to extend congratulations on the convening of the Sino-Dutch Joint Innovation in Water Technology Forum. I want to thank all the organizers, and I want to warmly welcome all the participants here. We know that water is the most important source of human life. Our research shows that water comes from outside of the earth. Water is the key to everything in China and abroad. Human civilizations couldn't do without water. In any time, anything, any development, any culture was related, is related to water. Water has led to civilizations. Huanghe River is regarded as the cradle of the Chinese civilization, facing global changes. Water is becoming a more and more complex issue. Now there is more uncertainty. China's water per capita is very small. The water tension is rising. It has become a bottleneck of high quality development in China. In water, China has done a lot of things. We moved water to the north. We have desalinized some seawater. We have comprehensively used water and dealt with water pollution. Water resource, water ecology, water science. We have worked on all these things, and they have been our priorities. Today, water is still an important and complicated issue. So today, our joint forum is very important. China and the Netherlands have great potential in collaboration on water. Water is a very important part of the national strategy of the Netherlands. It's one of its 9 priorities. The Netherlands supports the use of new technology in water. We can learn a lot from the Netherlands in their use of water technology. Leiden Water Research Center is a role model for us. This institution has a lot of success in its institutions and framework. Its innovation involving research institutes and businesses, and its collaboration with other countries, its management of IP, its whole chain of innovation, its incubation system, and its commercialization efforts all have a lot of innovations. We really should learn from them. Also, with support from relevant authorities, we are discussing collaboration. We truly hope that our collaboration can have a lot of progress. President Xi has said that water, green mountains, and lucid waters are very valuable. Water is a very important issue in China. So today, the meeting is very important. And it's more important in the context of our carbon strategy. Today, my topic is innovation drives future development. The Belt and Road is about innovation in technology. President Xi raised the initiative of the Belt and the Road. I think it's very important to peaceful development and win-win development. On this platform, we are developing Silk Road countries, Belt and Road countries, and the whole world in carrying out collaboration and achieving our common goals. Innovation is very important to addressing some deep-rooted problems. Innovation is about our competitiveness and future. To be innovative, you must be more open. So China has always wanted to open up and develop and carry out international collaboration in technology. We have worked a lot on this, and we have carried out a lot of projects. The past 4 decades of fast development shows that an open system is very vibrant. The closed system it will die. Due to the changes today, no country can close its doors and develop in isolation. We must achieve a win-win result. Also, regarding the Silk Road, technology cooperation can benefit everyone, and we can create a future in this way. So, the Chinese government, the technology community are promoting globalization of innovation so that we can contribute to humanity. We want to become a community of innovation in science and technology. Now we have a lot of several black swans like COVID and the Russia-Ukraine conflict, but crises generate opportunities. COVID shows that our futures are linked. Life surmounts everything, and our futures are all connected. COVID shows that we are all on the same boat, and this is a world of all human beings. So in the fight against the COVID, in addressing water and the environmental issues, they benefit all of us. After the Second World War, we had a long window of peaceful development. But now the world is full of problems. Some say that we are now in an age with most crises. There's a lot of uncertainties. So innovation globalization is now facing difficulties. The barley and wheat of Russia and Ukraine account for 1/3 of the world. Rapeseed oil, half of the world. Their rice production and the supply account for 1/4 of the world. Before the geopolitical crisis, food prices rose. In the past year, grain prices went up by 1/3, fertilizers up 2/3, oil prices also went up. So the crisis has increased the uncertainty of the supply chain. According to the IMF, now 30 countries, in terms of food and commodities, they have some restraints.
Regions in the world faced severe challenges in their supply chain, which led to rising food and grain prices. Such price hike would be global, and the situation would become more serious in the days ahead. Who controls the grain would be controlling the world. For a period to come, there will be severe inflation in the world. All of this would have an impact on global innovation. If we look back, 2,000 years ago, the Chinese emperor sent ambassadors to the West and opened the Silk Road, which connected Asia with Europe and become a bridge between the two continents and promotes civilization and exchange and interaction among different civilizations, leaving a huge impact on the world. In the Ming Dynasty, Zheng He sailed across the sea 7 times, spreading the Chinese civilization and culture to other continents. In the 19th century, after silk and ceramics, Chinese tea also went into Europe. After 1821, over 200 ships were trading on the Southeastern Sea. However, the Industrial Revolution in Europe also ended the booming sea trade. But the contributions of the Silk Road were still vivid even today. Last century, when the internet first came into existence, there had been profound changes in people's mindset and thinking, which led to several rounds of revolutions. Microsoft has promoted the development of IT technology across the world and also made Bill Gates the world's richest person. But today, there are more uncertainties in the world. Globalization is facing serious headwinds. Countries, even especially developed countries, have lost growth momentum, and the developing world are struggling to press ahead with globalization. Globalization is the defining trend. It is a significant feature of civilizations. Despite all the difficulties, China has been a staunch supporter of globalization. Today, we are hosting this joint forum with the Netherlands, promoting cooperation between the two countries in a wide range of areas. This is a testimony to our commitment to globalization and working together with other countries to promote peace and development. Declining global trade and rising gaps of income between countries are also causing concern among governments. This would give rise to new tensions and conflicts. President Xi Jinping and the Chinese people and the nation are working harder to promote Belt and Road Initiative that is highly relevant to our times. It will help the world rise from the challenges and move ahead towards prosperity. It is a road to future brightness and prosperity. That is the defining characteristic of the Belt and Road. No matter what kind of challenges we face in the world, China will be committed to globalization. The technological community in China will work hard to promote the globalization of technologies and contribute our wisdom to the further development of civilizations. The Belt and Road is also a road of win-win cooperation. As we move into a new era, the development of open economy is essential to China's international cooperation with other countries. Infrastructure among Belt and Road countries can still be improved. China produces over 1 billion tons of steel every year and over 2 billion tons of cement. Most of these commodities are up to international standard. They are of very high quality, and that is our advantage. In terms of universities and higher education, we are still lagging behind, but we have a lot to contribute to infrastructure development in the world. Our cost-effective steel, cement, and capacity in design and construction can help Belt and Road countries in their infrastructure development initiatives. By connecting the roads, we can connecting the capital flow and contributing to economic growth. China is also a world factory. However, with rising costs in labor, land, and other resources, some of the production capacity have been shifted to other Belt and Road countries. This is like what happened in the 1980s. There has been a structural shift of economic resources. Back then, China built a lot of special economic zones for fast growth. Today, we can copy these kind of growth models in Belt and Road countries, helping these countries build platforms to leverage the talent, capital, and resources to pursue better growth. We can work together with these countries to complement our economies and reinforce our strengths, help them tackle their challenges, and achieve sustainable development for these countries and beyond. COVID pandemic has reshaped the world economic structure and business landscape. The world today also faces changes unseen in a century. It's a profound structural change and a paradigm shift we are facing since the Second World War. We need an order-based international system. The new type of globalization will be the new driving force for post-COVID development. The pandemic might happen again in the years ahead. Life is always the most valuable thing. COVID has closed some businesses and factories and industries, but new types of business and industries are also emerging. Artificial intelligence, big data are booming. Smart healthcare, cloud based work, remote traffic and transportation, new scenarios are emerging. During the COVID-19, China has seen a boom of online shopping, telemedicine, and other internet-based industries. These industries have enjoyed explosive growth, and all have testified the power of technology and innovation. So technology is also forcing development of new ecosystems and new types of businesses. We would like to work with countries including the Netherlands to promote win-win cooperation and common prosperity. The Belt and Road is also an initiative for shared innovation. A new digital era is coming into place. 22 years ago, President Xi Jinping served as the governor of the Fujian province in China, where he promoted digital development there. After 2 decades, digitalization has penetrated into different aspects of our life, economical, political, and social. Today, everything is becoming digital. The trend of digitalization is reshaping our lives. Industries are becoming increasingly digitalized, and every aspect of our life is embracing this new trend. Otherwise, they will be phased out. Digital driven development in China is also ushering in an era of smart and intelligence. Last year, during the UN General Assembly, President Xi Jinping announced that by 2030, China will achieve carbon peaking, and in 2060, China will achieve carbon neutrality. The Chinese government has later on put forward guidelines to achieve these goals of carbon neutrality and carbon peaking. We aim to pursue a green, low carbon development path in order to achieve these dual goals. This has become a new initiative for China and a new top priority for the country. We would like to work with countries around the world to build a green global village, and water is definitely an important area in this great initiative. We hope that such cooperation would benefit both sides. China Scientific Research Center of IEAS is a network of scientists in China. It is a network of leading scientists and researchers in China. We have worked with colleagues in other countries to develop a platform for scientists from Belt and Road countries to work together. The Institute has increasingly become a platform for exchange between top scientists in the world and address common issues faced by Belt and Road countries. We are working hard to become a hub of scientific research and help contribute to global prosperity. Innovation is a defining trend of the world today. The new round of technological innovation and industrial revolution is booming around the world. Revolutionary technological innovation can happen anytime. Innovation has become the key to the new structural the restructuring of the global economy today. Technological innovation will promote innovation in all aspects of our life. We would like to work together with the Netherlands in promoting such kind of innovation. It is an unprecedented opportunity that is in front of us. Economic and social development of the world is diverse and open. Peace and development are the main theme for all. Silk Road cooperation will be a great opportunity for all of us. Let us work together to make international technological cooperation a bright spot in the initiative. Just now, Professor promoted great new cooperation ideas and proposals. We believe that we can achieve a lot in these cooperation initiatives and work together to build a better future. Talent is key to lasting success. It has always been the foundation of any nation's success and prosperity. China is working hard to develop a new innovation ecosystem where, with our unique advantages and institutions, as well as openness, we will work together with colleagues around the world to press ahead with partnerships and promote steady economic and social development so that innovation will thrive in international cooperation. Thank you for your attention.
Thank you, Minister Zhang Jing'an, for the important keynote presentation. Next, we'll have thematic report. The topic is innovation in collaboration model.
Innovation in collaboration model.
The Netherlands and China have a time-honored history in water cooperation. In the same era and facing new challenges, cooperation model continue to innovate. Without further ado, we would like to invite Mr. Rong Yining, Director of the International Department of the CSTF, to give us a presentation.
For promotion of science and technology and finance. Let's welcome.
各位领导、各位来宾
Dear guests, ladies and gentlemen, good afternoon.
all the online audience from Netherlands. 今天我很荣幸，可以做
It gives me great privilege to give you a presentation on behalf of our association to address all the audience in the Pujiang Forum. We would like to explore how we can innovate collaboration model. First of all, I'd like to thank the Netherlands Innovation Network China, and so that I can have this opportunity to share with you our progress. Next, I would like to thank the organizer, Pujiang Forum Organizing Committee. We know that this is a very challenging time, but still you managed to sponsor and host such a high-quality forum. It is because of this forum that we connect and we come to know new friends here. Today, I would like to talk about how to plan the future connected by water. The theme of our forum is Water Connects and Water Future. My presentation will give you a more detailed plan on how we can achieve that goal, that is to connect the water future together. CSFT. This is a sole national level civil society. In science, technology, and finance, we continue to explore new areas. We encountered a lot of difficulties in our previous work, in particular over the past couple of years. While we are pursuing industrial innovation, how to carry out industrial innovation, technology innovation, and how to carry out innovation in ecosystem, we encountered some bottlenecks. Actually, while we are working with governments, business communities, we have a feeling it is possible that we might need some breakthroughs, or we need some fresh perspective to stimulate new innovations. Science and finance are two sectors that Shanghai needs to great pride in, while Pujiang Forum is the most relevant forum to discuss these two topics, finance and technology. So, WESUS comes into the spotlight of us. The Netherlands is known for its innovation. It's a very prestigious European country for innovation. At a founding stone, there was a sentence from the Tao Te Ching. So the supreme level of the benevolence is water. Water benefits and nourishes everything. It is so interesting. At the other end of the earth, we see so familiar ancient poems or ancient script of China on the stone at the gate of WESUS. And they have become source of inspiration for us. WESUS adopts leading management models to maximize the synergy of talent, technology, and ecosystem. Their technological conversion rate is 40%. The successful rate of their technological conversion is 40%, leading the whole world. Their research findings are very influential. So their citation rate is 2.4 times the world average. This building is the base of WETSUS. It intrigued us. What are the good models behind it that they can bring such great innovations in the small city where WETSUS is located? It is rated by the United Nations of the International City of Innovation. It is really amazing. That's why we continue our discussion with WETSUS with a view to gain an insight into their great source of inspirations and driver behind their innovations. Today, we would like to give you some of our observations. What problems can water technology innovation address? On my slide, you can see 6 areas of problems. The first one seems very big. If you look at a global map, we are very familiar with this one, but what is the first impression at the first glance of it? The Earth is divided by different colors. We have different countries and regions. Only the sea is connected. If we change our perspective, this is from National Geographic's The World of Rivers map. You can see that all continents are connected by different waterways at various scales. This map is very striking. It is a fine expression of President Xi Jinping's idea, has a very profound understanding in today's world of more and more scarce water resource, how to treat water pollution, better preserve water resource, and realize sustainable use of water resource has become an inevitable choice of all countries. It has become a priority of international cooperation. The previous charts I showed you may lead to a thought. What are the key drivers? What topic can connect us? What can help us to break the deadlock in geopolitics? That is people's pursuit for high quality life, people's pursuit for safety and water security. These are the areas where WETSUS published their papers over the past few years. You can see that water technology is not only limited to wastewater treatment or as such. Water technology involves or are relevant to so many different subjects and, for example, waterborne communications. For example, Professor Bussmann talked about blue energy, the saltwater power generation, and, for example, robotic assisted pipe inspection, and microbiology or biomedicine, which is very popular now. They are all very closely tied to water technology. Why water technology enables interdisciplinary cooperation? We can say that no technology breakthrough is comprehensive or robust if it is only limited to one discipline. Water is related to so many subjects. Water is so inclusive. It helps to enhance the sense of trust and cooperation among different disciplines. That's why a water research project can involve professors from different disciplines, subjects, and clusters. In particular, on the platform of WETSUS. So it is water technology is a highly inclusive root technology. It is very inclusive. Third, water technology is very effective in addressing or breaking the bottleneck of technological conversion or commercialization. At the beginning of my presentation, I told you that Wessex is in a very small city in the Netherlands. The population of that city is only 80,000. Maybe in Shanghai, it is equivalent to a sub-district. However, such a small city is crowned as the global innovation city. It is also known as the European capital of water technology. Based on or centering on Wessex, it attracts over 100 water treatment institutions, companies, SMEs, startups, and institutions. And they have come up with the world's largest and most influential water campus, Leeuwarden, which is the most influential in the world. What is the role of Wessex between market and science innovation? They add an input, which is creativity. I hope that just imagine what is the feeling of water to you. Water emphasizes inclusiveness. It is just like the role of WhatsApp. I understand the needs of market. I have very good market insight. I know the latest progress of technology. So I can help the market to raise the requests for research projects for the scientific community. That's why a lot of professors led a lot of PhD students to realize the need or meet the needs of the market. Such an innovative chain of research boosted innovation of industry, which will in turn activate scientific research. Hence, we see a closed loop of innovation in science and industry. Fourth, it helps to pool the resources of different sectors. In China, I'm sure that in particular many leaders understand that there are so many high-tech parks around China. There are lots of industrial clusters. They claim to have similar approach. There is a research institute, there is a university or research institute at the center, around which the industry will be promoted by attracting different factors with a view or with a hope to establish a supply chain. In China, you see a lot of incubators as well as the industry, so-called industrial leading fund. But in contrast, West's infrastructure is quite different. They are so lively. Why? Compared with the existing models in China, they are quite different. In a summary, because they are very dedicated or focused on water technology, Wessex has a great spillover effect in water technology. They establish a multidisciplinary research plan driven by need because they are very strong in research and they are very inclusive. It is possible that for a certain topic, they can establish a dedicated platform with the CEW as available. We can very effectively translate the research findings from the labs. It is also because there are so many fundamental research. A group of incubators, financial services, and marketing, among other service providers, are also joining or are also distributed around the CEW. Why is that they break the barriers of resources and help to pool different resources. Waters is different from our model of work. They have a very strong link. Innovation as a core will drive or attract a lot of service providers. By integrating resources, I do not mean break the cycle or break the silo on geographical dimensions. The fifth, how to extend international cooperation through innovation. What is China? Western China is a pioneer project. We want to maximize the synergy between the Netherlands and China so as to break the bottleneck of using the market for the technology. We want to work with WESS to improve our model. As I said just now, they are very good in innovation model and ecosystem, a very strong research platforms. On its platform, there are a lot of multinational corporations, SMEs, and research institutes. But what is the benefit of China? China is very open. We are more than willing to establish international cooperation projects. We are willing to see the collaborative project, and we have very active capital, and we are quite open-minded. That's why the two sides can so complement each other. That's why the Waxis China emerges. We have 4 reasons to believe that going forward, Waxis China will grow bigger. It will integrate or pour more resources from the industry, financial sector, and research community so that we can grow the water research, water technology communities bigger. So this is just like a joke. Scientists are always connected to apple trees. This is the most favored analogy of Professor Gassman. Waxis is a very little apple tree. It takes 5 years, 10 years, or 20 years to grow into a very big tree. While it is ripe, it will bring you very delicious and yummy apples. For many years, it will always give you leading research findings and breakthroughs. Last but not the least, in our practice, we have a proposal. We need to enhance the public awareness on water technology. Why we need to focus on water technology? At the beginning, I said that it is not only a theme closely tied to the destiny of mankind. Everyone uses water every day, but no one feels that they are accountable to the conservation and protection of water. That's why in our research system, we need more than scientists, companies, or the government. We also need the attention and care from the general public and their understanding on the importance of water technology. On that front, on the WESS platform, we conducted one social science topic. So we launched one PhD research, the highly efficient water innovation model on its management theory and cross-culture universality and applicability. So we spent a lot of time on whether the WATMOS model is really fit in China, or what kind of modification we need to make it more suitable for China market. The second topic of PhD study, how to drive up social participation to enhance the impact of the transformational technology in water science. Water is relevant to everyone's daily life. That's why the innovation and breakthrough in water technology are also impactful on people's life. In the process of our research, we want to drive the growth of water technology as a whole. The WHO said, due to its fundamental role in society's life, water has a strong cultural dimension. Without understanding and considering the cultural aspects of our water problems, no sustainable solution can be found. It is very rightly so. It exactly reflects the problems of water technology, and it also offers us some food for thought. When we want to innovate water technology, culture aspects or culture dimensions should be included. So, in our Wexus China strategy, there is a project on water museum project. We want to use using the terminology of science. It is not a conventional museum. It is not a room of different exhibits so that visitors will understand the history. It applies the artistic means or the language to the layman to demonstrate the research finding of scientists to everyone. Science and technology are not only the privilege of scientists. Technology innovation and industrial transformation are not the privilege of entrepreneurs and businessmen, but they are closely tied to each and every person in this world. This is a new model we come up with artistic means of expression through the ways that are easily remembered by the ordinary people. We can showcase very leading water technologies and concepts. The roadmap of this water museum is as follows. First, Wexus has a history of 15 years in water innovation. They can offer us with plentiful science and technology innovation fruits or achievements. In China, we are going to carry out the follow-up research. That is to say, we will use the existing research findings to carry out another round of research. The final result will be the exhibits that are easily understood and understood by the general public. I would like to thank all the great partners and researchers who show great understanding and support to our project. Lastly, we will carry out a lot of public activities with a showroom, and we can carry out some cultural and creative activities to help the general public understand the leading technologies of water and the importance of water. By so doing, we want to advance the progress of water technology. This slide shows the concepts and messages we want to convey through our museum. It is a green, it is innovative organism. At the end of the day, we want to help more people to understand water should be cherished. And everyone can be devoted to the development of water technology. After several years of hard work, we want to leverage our own strengths with Wexus. Based on over 2 decades of water innovation management experiences from Wexus, Netherlands, we want to add a bit of Chinese or Oriental culture and wisdom so that those experiences from the Netherlands can rise and shine in China. We want to leverage finance to add wings to the water technology so as to move faster to forestall the weakening climate crisis and help to achieve the carbon neutrality as soon as possible. With the last beautiful scenery, we want to give you a great beam of hope. With our effort today, we can bring the world a very tranquil and happy life. Thank you.
Thank you, Rong Yining, for your very comprehensive and detailed presentation. Now, the last speaker for this section, Chu Hongbiao, party member of the Yixing Municipal People's Government, Secretary of the Party Working Committee of Yixing Environmental Science and Technology Industrial Park.
Party member of the Yixing Municipal People's Government, Secretary of the Party Working Committee of the Yixing Environmental Science and Technology Industrial Park, Director of the Management of the Committee of the Yixing Environmental Science and Technology Industrial Park. Now, let's welcome.
Distinguished guests, ladies and gentlemen, dear friends, I'm very delighted to have this video conference with you. We have said farewell to the longest and hardest summer. And in this cool autumn, we want to develop our friendship and achieve win-win cooperation. And now, we're very glad to participate in the 15th Pujiang Innovation Forum by the beautiful Huangpu River. We are very glad to meet with our old and new friends. Now, I'm very delighted to talk about the collaboration between Yixing and Henan. Yixing is a capital of pottery. It's a very unique and vibrant city of mountains and rivers. It's very hospitable. It has a lot of beautiful scenery and fields. Also, we had 4 prime ministers, over 500 high-level scholars, and in recent years we have over 30 academicians and over 100 university presidents. Yixing is in the intersection of these 3 provinces and very close to the Yangtze River Delta region. It has a very good geological position. It has a long tradition and it's also very modern. Our environmental industrial park has made us a capital of environmental protection. This industrial park was established in 1992 by the State Council. It's one of the first group of high-tech parks, and it's now China's only industrial park focused on environmental protection. It has China's largest environmental protection clusters. These companies are the fundamental to our development. We aim to develop a beautiful city, and we have this 2+3+N framework. We want to promote our energy conserving and the cables industries, so the 2 industries. Also, we are developing medicine and high-level manufacturing and other advanced industries. We have a global view and an open attitude. In internationalization, we have tried a lot of things. First, we have a lot of low-carbon resources. We have been part of the Water Innovation Alliance together with the Netherlands and Finland. We have set up 13 technology transfer centers. Second, we have some green ecological products through using international technologies and partnership between businesses and education institutions. We have zero carbon communities, toilets, buildings, and other ecological projects. We worked with academician Liu Qihui and set up the first sewage company. We recycle resources and achieve energy conservation. Now we have become circular, low carbon, and ecological friendly. Also, we develop a competitive talent environment. We develop our international communities. We want to meet with the needs of high caliber talent for work and life. We have this diverse talent market. Also, our industrial park leverages our natural environment. We have the beautiful mountains and the lakes. We sincerely invite you to visit our industrial park and feel Yixing and the unique charisma of our industrial park. We want to work with the Netherlands in the future. The Netherlands is a leader of environmental protection technology industries. It has world-leading philosophy in this area. The Netherlands has this new model. So this is upgrading in the carbon neutrality era. Also, it has sustainable agriculture. We know that this is called the capital of water treatment, also the capital of innovation. So we know about WETSIS. It has world-class research, also commercialization of 42% of its research outcomes. It's a leading water innovation institution. As our industrial park can carry out open cooperation with other countries. So we want to leverage this forum to work with the Netherlands and other countries. We want to work with industries from the Netherlands so that our industrial park and the whole country can benefit. We want to develop a offshore incubator with the Netherlands. We want to work with a water campus and set up some incubation center for environmental protection technologies. Incubation is in Europe and the industry is built in Yixing. So we are open to each other and we have integration and our talent can be exchanged. Also, we set up a new research facilities. So we combine technology, culture, and art. We use artistic ways to demonstrate our research results, and we develop future-oriented products. Third, we host the Sino-European Environmental Technology Innovation Forum. We want to discuss some challenges in innovation and work with European countries. We want to promote global innovation, collaboration, and develop a new ecosystem. We want to develop sustainable platforms for water technology innovation. We work with WETSIS, and we have a mechanism for bringing research results to China, and also we work on commercialization. Distinguished guests, ladies and gentlemen, science and technology know no bounds. We would like to work with all countries, all communities to achieve progress and contribute to low carbon development. Thank you, Chu Hongbiao. Thank you, Secretary Chu Hongbiao. Next, let's have a 15-minute tea break.
15 minutes coffee and tea break. We come back here in 15 minutes. Okay. 15分钟以后我们继续聊。女士们、先生们，坐在最后2排的同志，请坐在第1排和第2排。 最后我是主持人，最后两排的坐到第一排。
Ladies and gentlemen, those who sit at the two back rows, could you please move to the front rows, right? Please come to the front. Yes, sit in the front rows.
Okay. Ladies and gentlemen, now let's continue our today's forum. Now let's come to the second part of today's forum. And first, we still have the thematic speech section. 我们还是这个是主题报告这个环节。这个环节的报告的主题呢，是融合创
The topic for this session is integrated innovation.
Science, art, industry, and education. 我们大家都知道，水是人类的生存之本。
Water is essential to humanity. Innovation in water technology is not only limited to science and technology, it also incorporates other aspects. Next, we'd like to invite head of the Wessex Water Museum project, former head of the Water Mechanics Museum, Mr. Flores Gerard. The topic of his presentation is integration between science, culture, and education. Release of the Water Museum project. A very accomplished business leader. He's years, and especially in the cross sections of culture, such as not-for-profit organizations, museum, not Maximum, who inaugurated the exhibition. He also served as the head of a technology industrial park in the Netherlands, which had 50,000 students.
And the picture you see here is our former Queen Beatrix opening. What I show you here is a picture that was taken in Guangdong, in Guangzhou, and the Guangdong Museum of Art, where we had a large international exhibition for mechanical music. And you see in the background, you see a street organ, which is a very traditional Dutch musical instrument. And the street organ can also be taken to the street. That's because of its name. And I still remember the course. And this was not about water technology at all, but maybe one thing is interesting to tell that one of the most difficult things to restore in 18th century mechanics are mechanical waterfalls. And both in Beijing and in the Netherlands, we are very experienced in doing so. The next picture is in something completely different. It's a project that I initiated in the Science Park in Utrecht, which is one of the largest science parks in Europe, with 50,000 students and 27,000 people working there. And this was about zero footprint campus, about sustainability, and about what can you do with this knowledge in a very big campus. It was a very interesting thing. We had a lot of knowledge about sustainability, but it was not visible at all. And we tried with this project to involve artists and designers to cooperate with the professors to make visible in a very practical way with what kind of knowledge we had, and to cooperate with students to make this knowledge being used in daily life in this science park. And what you see here is we have the veterinary faculty in this science park, and they have sheep for academic reasons. And what you see here is a little installation to use the wool of these sheep to make the ties for the professors. It's very symbolic, but it inspired many people to think about what can I do myself to make this campus more sustainable. So, for instance, the old used coffee was being used in the botanical garden to grow mushrooms. And there was an artist who discovered that in the world, there are more places where you can buy Coca-Cola than there are places where you can obtain clean drinking water. So he designed a little machine which you can use to change co-inspiring a debate about water obtainability in the world. Something more about this project. How does it, what are we going to do? We call
Recording in progress.
An art gallery. And the picture you see here is a picture of Wetsons, as you know. And it's the place where all their new inventions are being displayed. And basically that is what we hope to do, but they're not new inventions, but new installations, works of art, which are related to water technology. What makes this project probably rather unique is that it's not only about artists making works of art or designers making works of design, but that it's based on a matchmaking process between the artist and the scientist. So the scientists and the artists closely work together in defining what kind of installation, what kind of work of art they can produce. And as was already told by one of the previous speakers, what we are planning to do is to create 20, maybe 30 pieces of art, installations, which can be exhibited to the larger public and which people can see in China, which will be the most important thing. But as Professor Buisman already said, maybe we can also display them at some time also in the Netherlands. What you see here is the website of the International Council of Museums, and it's very actual information, 3 days old. I just told you we call this project a museum, but maybe it's a little bit more. 3 days ago, the World Museum Organization made a new definition of museums. It's a very large piece of text, so I did not introduce it in my presentation. But there are 3 things in this definition which I would like to mention. The first one is that a museum is an institution or an organization in the service of society. That it's open to the public and that it is offering varied experiences for education, enjoyment, reflection, and knowledge sharing. And that's why we decided to call this project a museum. And when will this project be a success? When will this cooperation between scientists and artists, designers, a success? And I think the 2 first ones in this slide are the most important things. The first one is the public attention for the societal relevance of water technology. It was already told before, and maybe the example I mentioned at the Science Park in Utrecht is a good example of this. How can we show the public, the general public, how important it is, how important this knowledge is? And the second one is the interaction between artists and scientists. And I would like to mention the word serendipity. When you have an unexpected, creative cooperation, meeting, exchange of knowledge and ideas between artists and scientists, you can not only improve the work of the artist, but also inspire the scientist to become maybe even more creative in developing knowledge. So it is a mutual inspiration of both of these people, and that's going to make this project, I think, very unique and interesting and attractive for everybody who's involved in it. And of course, it contributes to some of the projects that are being presented also today, and the cooperation between artists and scientists in the Netherlands and China, and creating an ecosystem of cooperation as we are discussing this today. I'm going to show only a few inspirational pictures. This is one of them. This was a manifestation. It was in Germany in October 2021 until the beginning of this year. The Intelligence of Plants. It's an installation made by an artist called Thomas Feuerstein. This I find it very inspirational because it gives a very physical, artistic impression of abstract, complex, factual knowledge, and it invites people to discuss this, which is, I think, highly interesting and inspiring. This project, and I'm very glad that some of the logos and many speakers of the organizations I mentioned in this slide have already been presenting themselves or will do so in the rest of this conference. But I'm very proud that we can work together with this, not only Dutch, but very important Chinese group of organizations, and the speakers of CSTF and Yicheng Industrial Park for Environmental Science and Technology have already briefly mentioned this project, and I'm very glad that we met each other digitally today, and I hope that we will meet each other soon live. And the team is not only about organizations, but it's also about people, and I want to thank Professor Buisman not only for his introduction, but also for his inspiration and for his willingness to create this project. Elmar Fuchs, who will speak to you later in this meeting, and Chacho Yu, who has been of high value in helping us to create not only the team in the Netherlands, but also to have a very important and good team in China, Wang Yonggang and Dai Lai. We did not meet each other live yet because of the COVID restrictions, but it's a very nice idea, and very looking forward to meeting each other soon to discuss the further implementation of this project. And Yining Rong, you already mentioned this project in your presentation, and we have already met each other digitally a couple of times, and thank you very much for the inspiring cooperation until now. And then I want to conclude my presentation with some more inspiring examples of this serendipity idea. Anouk van der Pol is a Dutch designer. She's the curator of what we call the Embassy of Water in the Netherlands. And what she shows here is an installation in which you can see not the water that you consume during daily life, but the water that you use by buying products which in general consume much more water than you do as a person. So it's a very inspiring and attractive illustration of the water streams that are generated by people using water or buying products. Another one is a project in which I'm involved myself at this moment. Artists, designers who are using sludge and wastewater to produce works of art in ceramics. And they started with works of art, which you can see the right is an exhibition which is open at this moment in Leeuwarden, in the city where Wetses has its building, and Leeuwarden was also the European Capital of Culture in 2018. And I think this also was an inspiration for Professor Buisman to seek the cooperation between culture and science. This project started as a cultural, artistic project, and now it's developing into a further project because these artists are now working together with the ceramic industry in Friesland to develop production methods to get their artistic idea into sustainable production of ceramic products. Another picture I have for you, it's nearly the end of the presentation. It's about photography. The very famous photograph, I think many of you know the photograph of Justin Hoffman, of the swimming seahorse. There is also a photo, more recent, not this cotton swamp, but with a getting a discussion going, creating awareness about the importance of knowledge that we need to have good and clean and enough water in the future. We have a planning for this project that will probably take 1.5 to 2 years in 2 shifts to do this. These 2 months will be used to make this planning more concrete and to work further in how we're exactly going to do this, but we are planning now in 2 seasons to generate 30 works of art made by artists, not only from China, but also from the Netherlands, together with scientists from the global network of WETSES. It's a very fascinating project, and I look forward to the cooperation with all our partners, and I'm very glad that we have some visionary people around us who give a project like this a chance. Thank you very much for your attention.
Okay, thank you. Thank you. Now, let's come to the signing ceremony. 下面呢，我们有请科学技术部国际合作司前司长金晓明司长。
May I invite Mr. Jin Xiaoming, to former Director General of International Cooperation of the Ministry of Science and Technology.
Mr. Jin Xiaoming is the Director General of the International Cooperation Department of the Ministry of Science and Technology.
It is a great pleasure to attend this signing ceremony. There are 3 projects to be signed. The first, WETSES, China. May I invite Mr. Xie to the stage, and then we show a short video clip, and then we'll sign the agreement. The second project is a signing project of the Water Museum. It innovatively introduced the water management, water innovation management model from the Netherlands. The water-based public value has been integrated and recreated, which are exhibited in the Water Museum. With that museum, we want to establish a highly inclusive, flexible, and platform. We would like to invite WETSES representatives, academician Kais Boosman, as well as Ms. Xie Mingling. From CSTF.
We are very proud to sign today the Memorandum of Understanding with the China Association for the Promotion of Science and Technology and Finance. I wish that we and MESIA will work together on realizing the WETSES China dream in the coming years.
WETSUS 平台首个社科研究主题小组成立，旨在研究水科技创新更加高效的管理办法，以及创新成果形成最大化的社会影响力的方法。该研究由 WETSUS 协同荷兰莱顿大学、瓦赫宁根大学及格罗宁根大学与3家出资联合研发公司成员为宜兴环保产业研究院、天津开明咨询有限公司、北京象野建筑设计咨询有限公司共同研究，相关管理技术成果归3家出资企业独家享有。那么，下面有请签约人 WETSUS 欧洲卓越可持续水技术中心凯斯布斯曼院士、宜兴环保产业研究院院长高松先生、天津开明咨询有限公司人文科技整体研究院院长戴磊先生、北京象野建筑设计咨询有限公司首席顾问王永刚先生，请上。好，下面我们进行第3项签约。这一项是这个宜兴环保科技工业园与 WETSUS 合作共建新型研发机构。该新型研发机构为 WETSUS 科技成果的艺术化展示装置的前期研发平台，由宜兴环保科技工业园出资成立。WETSUS 中国唯一战略合作伙伴，中国科技技术基金会。
The CSTF will operate this platform. We would like to invite the signer from WETSUS, Steve, Mr. Kai Spusman, as well as from CSTF, Ms. Xie Mingling, Yixing Environmental Protection Industrial Science and Technology Park Administrative Committee, Mr. Wu Hongbiao. With that, we'd like to conclude this signing ceremony with online and offline participants. It's very new and successful. Thank you.
The signing ceremony is very innovative. Okay, now let's go to the next session, exhibition of Dutch innovative technologies. The first speaker is Peter Hack, founder of Red Stack. The topic is blue energy. Now let's give the floor to Peter Hack, the founder of Red Stack, to talk about blue energy.大家下午好，我是 Peter Hack， 我是 Red Stack 的创始人。
Red Stack, the first spin-off company from RedSys. We're focusing on the development and generation of blue energy. The worldwide potential of blue energy is to generate 1 terawatt of full sustainable, full continuous energy. Please let me explain to you how we're going to do it. Blue energy is the generation of sustainable power by contacting two flows of different salinity. For example, where a river flows into the sea, we can harvest large quantities of sustainable power. Red Stack uses the difference in salt concentration between two water flows to generate the sustainable power. We apply ion-selective membranes, two different ones, anion-selective and cation-selective, in stacks to harvest the power. The membranes are stacked alternately into a pile, a stack. The two water flows flow alternately between these membranes. The positive ions in the salt water move from one membrane to the fresh water. The negative ions move to the other membrane to the fresh water, in opposite direction. Add pluses to the one end or negative to the other end. A DC power supply. This technology and the hardware is the Red Stack, or unique product. In the energy transition, we are introducing and implementing various types of sustainable energy sources, like sun and wind power. They all have one problem. The supply of power is not continuous and often not predictable. No sun, no wind, no power. So we would need large-scale storage and need to accept the high losses and cost of such systems. Please let me further introduce our technology to generate sustainable and full continuous power. Blue energy can be harvested everywhere, where rivers flow into the sea, but also can be implemented in flood protection systems, pumping stations, and places where brines are discharged into surface water. In the Netherlands, the potential is to generate up to 1,750 megawatts on various locations. On the worldwide scale, the potential is 1 terawatt, or 12% of the world global electricity consumption. Please let me focus a bit on Red Stack. Who are we? We are the first spin-off company of RedSys, the European Center of Excellence in Sustainable Water Technology. Our know-how is backed up by the support of RedSys, 18 PhD studies done, and we have a patent portfolio of some 15 patents. We have a significant pilot plant operating in the Netherlands at TRL 7. This was supported by several EU funds. We also have good publicity. Our king, Willem-Alexander, came to do the grand opening, the ribbon cutting ceremony, and we were awarded the title of Dutch National Icon by the full board of Dutch ministers. Let's take a look at our pilot plant in the Netherlands, using seawater and lake water as sources for blue energy. And also, let's go back how we started. In 2004, model calculations made that 1 megawatt could be harvested out of contacting 1 cubic meter per second of fresh water into seawater, and a power density of 2 watt per square meter of membrane could be generated. This was confirmed in the laboratories of REDSYS only in 2011. And then we started to build our pilot plant. Our pilot plant was commissioned in 2014, but it lasted up to 2019 before our pilot plant under real-life conditions met the expected performance. Please let me elucidate how and what happened. Of course, clogging was a challenge. I'm not going to say that we do not experience any bio or chemofouling. You would believe that anyhow. But thanks to the right pre-treatment, the optimized stack design, the dedicated process design and operations, we can state that the fouling is now under control and does not have a negative impact on the performance of the membrane stacks and the power generation efficiency. Let me show you some examples of the cooperation between the REDSYS scientific staff, the PhDs, and the REDSTACK process engineers. We developed profiled membrane configurations to prevent the clogging, whilst ensuring good mixing and low hydraulic pressure drop. We applied model calculations in this design to enable us to design and shape the size of the profiles on the membranes to realize the optimal performance of power generation. Upscaling of a reactor is said to be a big challenge. We have been upscaling our membrane modules from small laboratory stacks with only a quarter of a square meter of membrane in the module up to stacks with more than 500 square meters of membrane module. That is 2,000 times bigger. We have measured and proven that during the upscaling, the efficiency of the system does not deteriorate. Per cubic meter of water and per square meter of membrane, the efficiency and the performance stays the same. You only have one more step to go to increase the size of the stack in another 4 times, up to 2,000 square meters of membrane. We have already designed a stack and the CFD calculations show that there is no risk of losing performance. Our core technology is the process know-how and process design and the membrane stacks, of course. Multiple membrane modules are positioned and connected in frames, and multiple frames are connected in equipment production lines. Let's take a look on the impact on marine life and ecosystems of blue energy plants. The water inlet system and the filtration system can have a negative impact on marine life. However, independent third parties, institutes like Deltares, DIOS, analyzed and measured the impact on the marine life of our pilot plant, the TRL7. They extrapolated it into a model for a 50 megawatt power plant, and the conclusion is that no significant environmental or ecological aspects can be expected on such a large scale, even in the sensitive ecosystem like the Waddenzee, a UNESCO protected environment. That means in industrial applications in harbors and deltas, there should be no problem implementing such blue energy plants. We are now preparing for upscaling into a demonstration size of 3 megawatt, using the same size of membrane stacks as will be used in future full-scale industrial plants. Despite the significant achievements we realized so far, and despite the enormous worldwide potential of 1 million megawatt, I must admit that it was not an easy job to do, and we still are facing some challenges. It's a new technology. It's not yet proven on a very large scale. We are worldwide technology leaders, meaning that we have to pave the road all ourselves. We are heading for the cost down curve, but that will be only after implementing on very large scale. In future cooperation with power companies, consultants, engineering contractors, we can look at the opportunities. The levelized cost of energy is calculated to be only 11 cents per kilowatt hour for the first full-scale 100 megawatt plant. And it will be going down to 5 cents per kilowatt hour, probably after 2040, once we have commissioned a couple of full-scale plants. This means that the levelized cost of energy is lower than the power from nuclear systems and also lower than storage systems. Of course, blue energy is full continuous, is eco-friendly in its power generation. The worldwide potential of 1,000 gigawatt, that should be the great opportunity. Thanks for your attention so far. I hope you are now enthusiastic about blue energy and its potential. And if you want to join making a great contribution and a business in the energy transition, you know where to find me. Peter Hack at Redstack. Thank you very much.
Very good. 下面呢，我们将有请
Next, we will give the floor to the project founder of water mining phosphorus recovery, Thomas Prott. Dr. Thomas Prott.
Water mining and phosphorus recovery with each.
Good afternoon. My name is Thomas Prott. I'm really happy to make this presentation today. And I'm going to tell you about one successful innovation of Vetsus and how it is successfully brought to the market currently. I'm going to tell you about phosphate recovery from sewage sludge. So first of all, I would like to go back to the birth of the project. Why did we start such research? So the current technology that recover phosphorus from sewage sludge are not yet fully optimal. For example, the best technology that we have to decentralize and recover the phosphorus straight at the sewage treatment plant is via struvite recovery, but the yield of the separation and the recovery is very low, and it's a maximum of 30 to 40% of the phosphorus. Alternatively, you can also incinerate sludge and recover the phosphorus via the leaching of the ashes, but this requires mono incineration, which is extremely costly because you need to build specific incinerator for this type of process. It means that for the moment, there are no decentralized technology available for phosphorus recovery from sludge that are coagulated with iron, while iron is extremely present in wastewater treatment work. So how did this collaboration start? So in 2012, Vetsus, together with TU Delft, one of our university partners, identified a market and a research gap in this field. So the market gap is that no technology exists, and the research gap is that the iron and phosphorus interaction in wastewater and sludge are not very well studied. In 2013, we reached out to some industrial partners, Kemira and STOA, the research organization for the Dutch water authorities, and proposed them to collaborate on this topic. They accepted, and since then, 4 other partners, mainly end users, join us on this project. As I was mentioning before, iron is commonly used in wastewater treatment for different purposes. It can be used in the sewer, for example, to control the sulfide production. It can be used to sediment, settle sludge, your organic matter, bind your phosphate, and a lot of this iron and phosphate will end up in the sludge digester where the biogas is formed. What's very interesting is that in the digester, if you have sufficient iron, up to 90% of your phosphate can be bound as one mineral, the iron phosphate mineral, vivenite. If you want to recover phosphorus from sewage sludge, it is then very interesting to target the recovery of vivenite. However, what we noticed, as you can see on the top right pictures, is that these vivenite particles are relatively small, from 50 to 200 micrometer typically. So it was very complicated, almost impossible, to recover them using gravity-based strategy, for example, hydrocyclones. Luckily for us, vivenite has an interesting property, is that it is paramagnetic, meaning that it can be attracted when you apply a magnetic field strong enough. We proved this concept at lab scale, and then when it was successful, we decided to upgrade that to go at pilot scale. In 2019, together with our partner in the Netherlands, we started the first pilot to upgrade and upscale this technology, working with a flow rate, with a feed flow rate of around 1 cubic meter per hour, which represents the sludge produced by around 20,000 inhabitants. The pilot was a success, and the product that you can observe on the top right was the vivianite particles, and after purification, we reached a purity of 90% approximately. What was extremely interesting is that 80% of the vivianite present in the sludge originally could be recovered via this process. Now, if you take a look at the overall process and the phosphorus flow for this innovation, that's what you can see. At the beginning in your wastewater, you have 100% of the phosphate. From this 100%, around 90% will end up in the sludge and be bound to iron. From this phosphorus that is in the digester, 80 to 90% will be bound as vivianite, and from this fraction, you can recover around 80% magnetically, meaning that the overall efficiency of the process, will be around 60%, which is very competitive compared to the other applications that are present in the market nowadays. And now you can wonder, but how is it possible and feasible to include this process to my wastewater treatment plant? Well, it's not very complicated because you don't need to retrofit any wastewater treatment plant. You can just put this unit immediately after the digester, fill it with your digested sludge, separate the vivianite on one side that you can upgrade, and your vivianite as in a normal process. After the vivianite is separated, you can upgrade it and, for example, split it into phosphorus that can be repurposed as fertilizer and iron that can be reused to remove additional phosphorus or to control sulfite in your wastewater treatment plant. After you have recovered the vivianite, you have several options for valorization. You have some direct valorization application, for example, in agriculture, but as people could think, vivianite will not be used as a phosphorus fertilizer because it contains a lot of iron. So it's a bit limiting. However, vivianite has potential, and this potential is already being used as an iron fertilizer. For example, in the south of Europe, where they cultivate a lot of olive trees to produce oil, a lot of these trees are suffering from what we call iron chlorosis, meaning an iron deficiency, and vivianite is already used as a complement for these trees to fight this iron chlorosis. Vivianite can also be used as a pigment. For example, you can see this famous painting from the Dutch painter Johannes Vermeer. The dress of the Prochorus, this blue-gray shade, was originally made of vivianite by this painter. Other ways to upgrade the vivianite is to reuse it as phosphorus in fertilizer and as iron as coagulant, or another high-end application that still needs to be studied is to use the purified vivianite in lithium iron phosphate batteries. The next steps of the project are one that we have undertaken and that we are performing at the moment is a mobile pilot unit that will go to different countries, Denmark, Netherlands, and Germany, to be tested on several sludges, and that will bring us several new insights. For example, we will know how this installation works on different sludge type, digested, undigested sludge, the influence of the viscosity, the influence of the crystal size of the vivianite, the long-term performance, and of course, it will produce sufficient vivianite so then we can work on the upgrading of the product. Some lessons learned from this project. The development of the technology went quite smoothly, despite some problems that you can always encounter during upscaling, because the market gap was clearly defined at the beginning together with SteerDev, meaning that it was not so complicated to get the partner on board because the business was pretty clear. There was a need, and we came with a solution. The different stakeholders, the end users, technology providers, and universities were involved from the very beginning, meaning that we could always get their feedback and tune the project depending on the opinion of everybody. Also, the multidisciplinary approach that we took helped to quickly tackle the opportunities and also resolve the problem. For example, this technology of magnetic separation, this is not a technology that is coming from the wastewater treatment field, but actually from the mining industry. Some learnings from this project. the road from idea to product is long, but the early collaboration was actually very beneficial because it created trust between the partners and it made the project develop much faster. The last point that I would like to mention is that the regulatory acceptance of the new product, in this case Vivenite, is still too slow for resource recovery technology, and this is our next big challenge, is to make Vivenite be seen as a resource for the future and not as a waste anymore, even though it is harvested from sludge. With this, I would like to thank you for your attention.
Thank you, Mr. Thomas, and made a good speech. Besides the audience here in this meeting room, we have also many audience online, and they have some questions. So now, do you have some questions? Mr. Thomas, please ready to answer these questions. Okay, please.
So because in the audience, if there's no question, I will first raise a question that we received online from our Zoom connection. And the question is, first starting with a compliment. Very nice presentation, Dr. Prott. The question is, what makes the process economically valuable and how much economic benefit can you save with this technology?
Thank you for the question. That's a very interesting point. At the moment, the Vivenite product that we recover has no value because it is still considered as a waste. This is, of course, going to change after the end of waste status will be reached. But what makes the process economically feasible is that when you will remove this Vivenite from sludge, you will decrease your sludge volume, and so you will decrease the sludge disposal cost. The sludge disposal costs, for example, in the Netherlands are very important. It's, for example, 300 to 400 euros per ton of sludge that you have. And if you remove, for example, 15% of your sludge, which corresponds to the Vivenite share, you will save 15% of this cost, which will then give you a return on investment for this kind of process of 3 to 5 years already, which is quite a good number for innovation in the water treatment world.
Okay.
Thank you very much, Dr. Prott.
Okay, very good answer. Thank you, Thomas. Okay, thank you very much. Okay.
Thank you.
Next speaker. Next speaker is also will speak online. He's the project founder of the ELMA Fuchs. And he will talk about applied water physics and vortex aeration. 下面呢，我们要请艾尔玛·福克斯博士，他呢跟我们来做这个报告呢，就是有关于应用水物理和这个是漩涡增氧技术的这样一个报告，大家欢迎。
Well, ladies and gentlemen, good afternoon. My name is Elmer Fuchs. I'm WETSUS program manager. And I would like to thank the organizers for giving me the chance here to talk about applied water physics. Now, applied water physics is one of the WETSUS themes, and the core of applied water physics is a positive definition of physical water quality. We aim to identify, quantify, and improve this water quality on a more fundamental level than the previous speaker, because we think that if you want a big breakthrough, then you need actually a big change. And to start with, for example, we can look at the electric treatment of water. When we take, for example, an experiment from the 19th century by Sir William Armstrong, who filled 2 beakers with pure water and then added 2 electrodes, he created back then a phenomenon that nobody understood, the so-called floating water bridge. We looked at this experiment again because it has some unique properties. It's not only nice to look at, it also contains new science. Now, if you take, for example, a look at this video, where you can see actually that the water is jumping up the beakers and flowing upwards, you could already guess that this is not normal water anymore. And indeed, over the last 15 years, we could discover that the water in the beaker is no longer normal bulk H2O, and also the water in the water bridge actually is water in a new liquid phase. And you can also see that by looking, for example, at the infrared emission of the water bridge, as you can see on this video, which is beautiful in the sense that you see that it's radiating thermal infrared emission, meaning that there's a temperature change, the water bridge is slowly heating up. However, when you take a closer look, you see that this is not a uniform process. No, the water bridge actually creates these beautiful patterns where warm water and cold water are mixing. And when you look at this spectroscopically, and you compare it to bulk water, for example, here, two water emissions, 47 and 37 degrees Celsius, you see that the emission is fundamentally different from bulk water because there's an extra intensity here at the low wavelength side. And you can also see this using a thermographic camera here, the water which is brighter here at the low wavelength compared to the longer wavelength. And we have found out that this is due to a non-thermic emission resulting from a protonic band transition. Now, a protonic band transition is something that you can only have normally in ice. So we did investigation with an ultra-fast vibrational energy relaxation investigation where we used ultra-fast infrared lasers to excite this bond here. Now, depending on how fast this bond relaxes, you can find out whether this molecule is surrounded by liquid phase or by the solid phase. And when you do this and you look at the absolute numbers, you see that you have liquid water here with a relaxation level of 740 femtoseconds, then you have ice with 384 femtoseconds. And you would expect liquid water, the water bridge, to be up here, but we found out that it's inside the phase transition, meaning that we have a new phase of water here, a new liquid phase that has not previously been found. And we have also confirmed that with Raman spectroscopy. And this phase is extremely important because it's also present in our cells within our body. So we consist of a new phase of water, new liquid phase of water with coherently coupled molecules. Looking back at the beakers, we can also see that we have proton production here and OH minus production here due to electrolysis. And I told you before, the water in the beakers is also very important and very interesting as well. Why? Because when we break this bridge, we somehow take out the water from the equilibrium and we create something that nobody has thought that could exist, but it can, which is charged water. We have a patent for that, to produce this charged water for cleaning agents, for energy drinks, etc. And we also got a prize from the Institute of Physics. It was our paper on the discovery of charged water was highlighted. So you can see that actually with electric fields alone, you can do a lot of new science with water, lay the basis for a lot of new technologies. Now, let's go to hyperbolic vortices, part of the title. This is a concept invented by the Austrian Walter Schauberger, son of which is now a company member of our team. And the concept is that you let water pass through a vortex and thereby it sucks the air in by itself. When you compare this to commercial aeration devices, you see that the actual efficiency is much, 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 much higher. The KLA, the volumetric mass transfer constant, is much higher than that of commercial systems, which is why we continue to investigate this and which is why we also filed a patent. And we also recently got a prize on the student for the best and most sustainable national thesis on this subject. And at this moment, we are trying to upscale this to apply it to actual wastewater treatment. We can now combine the electric treatment from the first part of my presentation with this vortex treatment, for example, for an electric discharge vortex. Now, why would we do that? Because if we do a discharge of plasma into water, we can destroy organic molecules, for example, from a medicine that is still in environmental waters present. And normally this process is not that efficient, but if you combine it with the vortex, then you can use all the gases that are produced here in this discharge. You can use them, they are dissolved very efficiently into into the system. And as you can see here, we have a prototype of such a plasma vortex device, which very efficiently destroys organic molecules inside of our system. Finally, let's look at what we do with magnetic fields. Now we are using very slow, very weak fields. My apologies, in contrast to the previous speaker. And in order to understand what magnetic fields do, very weak fields do, let me talk about calcium carbonate. At all times when you have a calcium carbonate solution, you can only measure about 50% of the calcium carbonate as ions. The rest is present as dollops, dynamically ordered liquid-light oxyanion polymers that look like organic molecules. You can also visualize them in a little bit larger as amorphous calcium carbonate crystals. And why do we need these? Because they are present, for example, also in natural waters, as shown here by the late Professor Eshelben Jacob. And Professor Coe from Ireland Trinity College has a hypothesis saying that a magnetic gradient of a very weak field can dephase the spins of the protons of bicarbonate ions on the surface of such dollops in order so that the protons can then be substituted by calcium ions, and then you have a faster growth of these dollops and you have a faster nucleation. Thereby you can influence the water physics with a very weak field. Now you can calculate this with this formula. You need to map the magnetic fields in order to find out what gradient you have. We can do that at WETSUS. We were using water core magnets, which are very weak magnets with sufficiently strong gradients in order to create that. And then when you do the experiment and you count the nanoparticles in the system, for example, you see here, independent from the starting concentration, you get more nanoparticles in the treated system. And of course, you get fewer ions, which means that the impedance is increased. So you have two independent methods to measure the effect of that magnetic treatment with very weak magnets. Also here, visually proven, after treatment, you have more of these small crystals in the water. And of course, if you have natural waters, you don't only have ions in there, you also have bacteria in there, a whole ecosystem. So when you magnetically treat a natural water, drinking water, for example, you have to think about what does the change of the calcium configuration in the system do with the microbiome. And we have found that next to this hypothesis, we also have a direct influence of the magnetic treatment on the microbiome. With the right magnetic field, you can push the growth of the bacteria that actually keep the water clean, and you can reduce the growth of the bacteria that actually are pathogenic and that you do not want in your system. These are very recently published. And at this point, I'd like to thank my whole team of researchers, Xiaxia Liu, Thales Arai, Roman Klimenko, Nigel Dyer, etc., all the researchers at WETSUS and the professors, of course, who supported this research, who made applied water physics the largest research theme of WETSUS possible. I'm sorry if this was a little bit hasty, but due to the time limit, I could not go into more details, and I'm happy to answer any questions. Thank you very much.
Thank you very much, Mr. Fuhe's speech, made a speech online. And also we have the questions here in Shanghai. And we have the question, okay, yes.
All right, we do have another online question from our audience watching the show live via Zoom. Also starting with a compliment, thanking you very much for the great presentation. And the question is, could you please elaborate more on the economic value of this new type or phase of water? And what is the economic indication of such an impressive discovery? And please speak a little bit slower so our translator can keep up. Thank you very much.
My apologies. Of course, I can speak slower. I just wanted to put in as much information as possible. Please understand it from my perspective. The economic value of the new phase of water is very difficult to estimate at this point. You see, the phase that we discovered, this new phase where the molecules are vibrationally coupled, is a sort of a coherent phase. It's a phase that has some properties of the superfluid, and it's very likely, although we have not proven it 100%, that a lot of the water in living organisms consists of that phase, meaning that if we want to understand how medicine works within our body, we have to study this new phase of water. We have to continue to investigate it and find out about its properties. So it's very difficult to say at this point what impact this new phase will have. However, that it is very important to water in living systems, that is a fact. And the rest will, for the rest, we'll have to do more science in order to find out.
Okay.
Okay, thank you very much, Amar.
Okay, thank you, Mr. Fuchs. Okay, thank you.
Thank you.
Thank you. Okay. 我们这一个演讲嘉宾呢，这一段的最后一个演讲嘉宾呢，他是来自于南方科技大学。
The last speaker is Associate Professor from Southern University of Science and Technology. He graduated from WETSIS. He will talk about electrochemistry. Good afternoon. I'm very delighted to talk about recycling of phosphorus. You may wonder, I'm from Southern University of Science and Technology. Why am I here? Before joining this university, I was studying in Wageningen University and WETSIS. And today I will talk about my work in the Netherlands. I came in 2021. From this, you can see I will talk about the recycling of phosphorus. I think this is not a strange topic. In China, this is a very important topic due to three reasons. If phosphorus is released to water, there will be a lot of issues. There will be negative overnutrition. Also, phosphorus is needed especially in agriculture, in fertilizers. It's very important. From this photo, you can see on the left there's phosphate. On the right, no phosphate. So you can see this contrast. But it's very unfortunate that phosphate mines are very scarce. Usually we can develop that from the crust. But with a lot of utilization, phosphate will be used up. It's estimated that in the next 100 years, if we keep the current rate, phosphate will be used up. For China and EU, it's a very important topic. For the Netherlands, in Europe, they almost have zero phosphate. So they take this issue very seriously. Phosphate is now one of their 30 most important things. China's output is number 2 in the world, but only accounts for 4.6%. Most comes from Morocco and the West Sahara. China accounts for 4.6% of the phosphate mining, but our output accounts for 16%. It means that we use a lot of phosphate. Considering our population, very soon in the future, China will run short of phosphate. Phosphate or phosphorus has many characters. First, it's a pollutant, but it's needed. How can we do this? What can we do? We can recycle it from sewage water. So in this way, we can protect the water. We can also recycle the phosphorus so that we can have more phosphorus to use. Scientists around the world have studied this issue. We have a lot of ways to deal with phosphorus. We can use biological measures, we can use sedimentation measures, we can use mixture and other methods. They have different approaches. We know that we take phosphorus from water, so it's no longer in the water, it becomes into a fixed state. We wanted to make water cleaner, but so these methods didn't really think about the recycling of phosphorus. So for example, in a municipal sewage plant, we have efficient ways of dealing with phosphorus. But in this way, the phosphorus we get from the water cannot be absorbed by plants. And you need to take many measures to recycle the phosphorus. So we have this new approach. This is a sedimentation technology. You don't need to add anything, but you can still take this. We know that calcium exists. We use CAP precipitates. We use this electrochemistry system. We have the positive and negative cathodes. We exert some currency, and there will be this reaction. The pH value goes up. You don't need to change the pH value of the whole solution, only the solution near the cathodes. And then we will have the phosphorus particles, and you can achieve the separation. Next, I will give you a detailed case and talk about the potential. Here, so we have sewage water with the cheese. From this table, you can see that it has a lot of salt, a lot of phosphorus, a lot of organisms. You can see there is also a lot of calcium there. So the mole value of calcium is about 2.0. But the only problem is pH value 4.4. It's very acidic. You can add some alkaline substances to achieve the precipitation. You can cause the precipitation, you can cause the chemical precipitation. In this process, there is a high concentration of water, so you need additional ways to deal with the sludge. If you use electrochemistry, the sludge is very little. We have verified this, and we designed this electrochemistry system. We tested this system for over 170 days. The effect was very good. And then we evaluated the things we recycled. So how does it compare with phosphate from mines? So the result is very good. First, the rate of phosphorus. Second, the ratio of heavy metals, and also the recyclability of the substances. So this is a summary. So I want to say three things. First, the recycling of phosphorus from sludge is very important. Second, the electrochemistry can help us recycle the phosphorus. Third, this technology has great potential, and we need to further evaluate this and commercialize this. This is what we are already working on. Thank you for your attention, and I look forward to your comments.
Thank you very much, young man, young professor. 好，现在呢，我们进入今天我们论坛的最
Now we'll move into the last part of our forum today, the round table. The topic of the roundtable is low carbon and water management, dual action to fight climate change. We are going to invite 5 panelists to this roundtable. They are Mr. Wang Fengqing, Distinguished Professor from School of Oceanography, Shanghai Jiao Tong University.
Distinguished Professor of School of Oceanography at Shanghai Jiao Tong University. 第二位嘉宾是孙丽杰女士。
Madam Sun Lijie, Secretary General of China Association for International Science and Technology Cooperation.
Association for International Science and Technology Cooperation.
Mr. Ye Qinghua, Senior Scientist from Deltas.
Senior Scientist at the Delta Airways. 这下一位专家呢是胡延华。
Mr. Hu Yanhua. Madam Hu Yanhua is from China Association of Senior Scientists and Technologies.
And the China Association of Senior Scientists and Technologies. 最后一位
The last panelist is Mr. Fan Mao, consultant of China Association for Science and Technology Finance.
As China Association for the Promotion of Science and Technology and Finance.
Welcome to all the panelists to the round table. Distinguished leaders and guests, good afternoon. I was entrusted by the organizer to moderate this roundtable. The topic of this roundtable is first, low carbon, second, water, water can bring both benefits, disasters, and hazards. And also it covers topics such as water technology and joint innovation. It's, in my view, a very serious topic due to climate change, global warming, the melting of glacier, floods are coming to us. It is also a very dynamic topic as humanity is waking up to this crisis and taking action. The roundtable today is a proactive effort made by us in this regard. Through this roundtable, we are going to push this forum to another level. Our panelists are all highly accomplished in their fields. So I just have to be very brief in introducing them. Dr. Ye Qinghua is joining us online. He graduated from Zhejiang University in 1998. In 2001, he got his master's degree in coastal line engineering. In 2006, he got his master's degree from the he started his PhD study at Delft Technology University, and later on he joined the Delft Research Institute, and also development of a 3D model. I think he deserves a big hand. This is a low carbon forum. So the applause will also be in line with this low carbon scene. So let's go straight to Dr. Ye. Can you hear me? Yes. Hello, Dr. Ye. We just introduced you to our audience. It's our great pleasure to talk to you in this way. Our topic today is low carbon and water technology. So we would like to ask you to share with us some information on this area in the Netherlands. The Netherlands is very strong in water technology, and it also takes rising sea level as a very urgent issue and a top priority. So what are the strategies the country has taken to address this issue? Yes, thank you, moderator. Can you hear me clearly? Yes, loud and clear. I want to thank WESS, the Shanghai Science and Technology Commission, and the organizer for inviting me to this great forum. I'm glad to see you all, and especially to hear all the new progress in the area of water management and technologies. Rising sea level is a topic of great interest in the Netherlands. What the Dutch has done to address this issue has become an example, a role model for the world, and it often is regarded as a pilot. About 1/3 of the country's land is below the sea line. The rest 2/3 are actually below the tide level, which means every day, twice, it will be immersed by the rising sea tide. So for such a low-lying country, the rising sea level is truly a serious threat. It's a life and death issue. That's also the reason behind the extensive research on this topic and the great interest all the data we've collected, the modeling have been the proof to that. Of course, there is still controversy over the question of how much the sea level has risen so far. It is affected by the height of the bay and the way of calculation, the valve, the water supply system, the treatment of the inland waters, the engineering technologies adopted to address the inland lakes created as a result of the rising sea levels. So actually, it is an issue that has an extensive impact on a lot of aspects of a country's life. So it's a systematic project. The technology authorities of the Netherlands, the science community have, since very early on, regard this as a national issue. The main response is that in the Netherlands there's a Delta Commission, which is an organization that's dedicated to grand projects like the South-North Water Distribution Project in China. So the Delta Commission will be in charge of all the related policies and strategies. It takes a global perspective from Antarctic to the Greenland. They watch the change in the sea level and develop a systematic approach to deal with this issue. And they measure these specific changes in sea level and processing the data. Response to potential scenarios, and in terms of the timeline, they will make plans for the next 5, 10, even 20 years. Research-wise, and application of technologies, execution by businesses and the private sector, issues such as land planning and others, they will give a comprehensive planning, and they would ensure smooth operations, which are supported by funding. From the year of 2020 to 2035, they have a Delta Fund worth 1.4 billion euros every year to deal with the rising sea level. To sum it up, the Delta Institute is a national water think tank. It has communication and cooperation with many Chinese organizations in the field. Ambassador Hertz at the beginning also mentioned its cooperation with the East China Normal University and other colleges in China. We work with the Ministry of Transportation, the Management Committee of the Yangtze River, Environmental Protection Bureau in Shanghai, among others. All of these are our partners for many years, and we learn from each other. I think one of the things that the Dutch has been very successful in this area is that it does not take this as a specific issue. It has a very global perspective of looking at this issue. It takes a very long-term view. The plan covers from now to 2035, even beyond that to 2050 and even further. And within the IPCC scenario, what might happen in this period?
And then they will zoom in to this year and next year. Second, in the Netherlands, the research and application are systemic. Government, research community, and administration, engineering, even the public awareness raising activities, they have a very good systemic approach. For example, April the 5th is a festival on the sea level rise. There will be publicity activities in a lot of primary schools. The third feature is their long-term planning. Long-term and consistent effort. Now they are in the plan between 2020 to 2025. The previous round is between 2008 to 2020. Of course, every 5 or 6 years, they are going to review the implementation and make some adjustments. With that long-term planning in place, the funds are already earmarked for this project before 2035. This plan is being modified and updated regularly. I think this is a very good approach for China to learn. Thank you. This is my part. Thank you. Thank you for your observation. I think that the applause just now from the floor means that we all heard about, and your points are very well taken. Thank you. The next panelist is Ms. Wang Fengping. Wang Fengping from Shanghai Jiao Tong University, Distinguished Professor of School of Oceanography, and she is also the recipient of an award on outstanding achievement in oceanography, and she joined the deep sea research project 3 times, and she is now the International Microbiology ISME ambassador, as well as the international director, European Ocean Science Exploration Equipment Committee member, IODP, China Science Committee member, China Paleology Committee member, as well as a series of titles. She is the Deputy Chief Director, as well as a member of many international journals. He made great contribution to the development of the subject, as well as China's reputation in all these areas. Thank you, Mr. Moderator. Ms. Wang, would you please share with us your views on the role of ocean in our carbon campaign and carbon effort? How can people better leverage the ocean to reduce the carbon emission? Thank you. Mr. Moderator, it's a difficult job for you to read aloud all my resume. It's very technical. I'd like to thank Wessus and Ms. Xia. We have a very special bond with the Wessus. It's a great pleasure to be here. This morning, In Jiao Tong University, we worked with Tongji University and Po Center, as well as several other universities in Shanghai, in hosting a forum on ocean and climate change. So I would like to give you a very brief account. First, the importance of ocean. Ocean covers more than 70% of the Earth. Ever since the start of Industrial Revolution, CO2 emissions, almost 1/3 of the CO2 has been absorbed by oceans. That is to say that oceans have already helped the mankind to absorb a lot of carbon emission. They made great contributions to humankind. Now the target is carbon neutrality. That is to say that we need the ocean to do more. How to increase the role of ocean? We need the collective wisdom of humanity, not only from scientists, but also from business community, the general public. In this morning, in our forum, one report is given by academician Jiang Yuanshi from Xiamen University. He is a sponsor of a ONCE project. ONCE means the negative emission of ocean. That is to increase the carbon benefit of ocean. What are the appropriate means to increase or expand the carbon benefit of ocean? In the science community, yes, we can say there are some proposals. However, all of these proposals need to be more scientifically reviewed or assessed. For example, starting from 20 years ago, we started a project, but it was suspended. What is called fertilizing the ocean. What does it mean? As is known to all, in the southern part of ocean on Earth, there are a lot of nutritions, but it's not very productive. What does it mean? The productivity is low. For example, on the Earth, the trees can absorb CO2, but in the ocean, zebras are absorbing CO2s. Actually, they absorb 50% of the total CO2s on Earth. Just imagine, sea is so vast and big. There are so many nutrients, but the zebras are very small. And all the amount they absorbed are relatively small because there's a lack of pharaohs in the ocean. That's why last century, John Martin raised very famous schools of thought. If you give me some iron in the sea, I can give you back the ice age. That is to say that if we can just put a lot of iron, then we can just foster the growth of the algae, and then the algae will help to absorb more CO2 than ever. Well, in the history, while the CO2 was very low, back then we can see that we know that the content of iron in the ocean was very, very high. So 20 years ago, there was a project called Fertilizing the Ocean with Iron, More Iron. And the projects were kicked off. And it was quite effective back then. If you add iron into the sea, into the ocean, the algae just grew very fast. However, the project was suspended because it might cause possible or potential biological or ecological problems. Yes, we grow the algae, but down the road, what will be the impact of these growing algae on the ecosystem? We have no idea. If we will scale up this project of fertilizing the ocean, it is kind of geological, it is a mass project. According to some NGOs, this is illegal to fertilize the ocean with iron. Now, in the context of the double carbon targets, this old project was again proposed. Scientists such as the Woods Hole from the United States started to discuss it again. I think that more research is needed. If we add iron into the ocean, what will be the long-term impact on the ocean or the whole ecosystem on Earth? We need a comprehensive review or assessment to see whether this is a safe way of fertilizing the ocean. Another possible project is man-made upward or downward flow. What does it mean? In the ocean, we can look at the sea as different layers of blanket. At the surface, because of the sunshine, because of the algae, they attract a lot of nutrients or nutrient salt or nutritive salt. If we can just imagine in many parts of the ocean, if there is an upward flow, then it will bring about a lot of fish swarms. Nowadays, there are different strategies or tactics. My point is that, engineering speaking, it is possible we can develop or generate man-made upward flow so as to redistribute the nutritive salt at the surface. And we can also increase the for example, we can just change the acid level. Wow. And final analysis, ocean is such a big area. In future, I'm sure it will be a great place for us to benefit or for us to reap the carbon benefit. But I must say that now these projects are only known to scientists in this field. We need to pool the wisdom and resources of different sectors. For example, we want to increase the level of the alkali, but we cannot simply put the minerals into the ocean. It might possibly cause the biological or ecological crisis. Everything needs long-term monitoring. We are faced with daunting challenges. Scientists and the general public must work more. We have a long way to go. Okay, this is my part of the presentation to your question. Thank you, Ms. Wang Fengping. All panelists in our session are very smart person. They are the expert in their own disciplines and they are very logical. So they have made very clear points, which spare my trouble of reiterating their points. My only role is to keep the pace. We will leave some time, Q&A time for the floor. Just now, Ms. Wang Fengping the remarks is a very natural transition to the third panelist topic.
We have with us Sun Lijie, Secretary General of China Association for International Science and Technology Cooperation. Sun led the writing of a very important report on international technology transfer and country research, case studies, and Belt and Road Science and Technology Cooperation Progress Report. Also, Sun compiled some materials on international collaboration. She also did some study for Shandong, and also she studied the past 40 years of reform and opening up. Thank you. I'm the Secretary General of CISTC. I think this one-sentence introduction is enough. Ms. Sun works on international exchange. We know that water has boundaries, but the flow of water has no boundaries. So, Ms. Sun, please talk about technology, cooperation, and international cooperation and innovation, in particular water technology. What's the role of this kind of international cooperation and innovation, and what are the approaches to that? Thank you, moderator. I try to be very low carbon in my response. I'm very delighted to attend this China-Dutch meeting on water technology. Through this meeting, very good technology and talent and funds from the Netherlands can be brought to China. Now China aims to achieve high quality development and opening up. So it's a very good trend. So I'm very delighted to be at this meeting. I also feel I have a great responsibility. Our association is a people-to-people association established in 1992. So it's been 30 years. With the Netherlands and with other countries, our association has been playing its unofficial role. So this is related to today's topic, whether it's about carbon or water or sustainability. We need participation from the public. I didn't study technology, but I graduated from Chinese University for Geology. My alma mater is very good in water and environmental studies. There are a lot of academicians and experts in my alma mater. Before coming here, I told my alma mater about this very good program from the Netherlands. And when Dutch approaches or programs come to China, my association and my alma mater hope that we can play our role in personnel exchanges. Next, relating to carbon neutrality, in China, there are some positive voices, but they lack international publicity. In 2006, our association won a certification from the United Nations that allows us to organize Chinese universities, scholars to carry out bilateral and multilateral meetings with the UN. So we can express our voice. We have with us scientists, including Ms. Wang, who spoke just now. So today I want to start this initiative. In the future, whether it's about water technology or carbon neutrality or biomedicine or new materials and other areas, I hope we can be of service to Chinese scientists so that they can appear at the UN. I don't know whether you are satisfied with my reply. Let's give her a warm round of applause. Thank you, Ms. Sun. I was just reminded that we have 20 minutes left. We need to ensure the quality of our talk. It's a low carbon discussion, but I don't think we should be too low carbon in my introduction. The next speaker is Hu Yanhua. He's the consultant of CSTF and from China Association of Senior Scientists and Technologies, and also is a consultant of the Shangjing magazine of Xinjiang. Also, she is participated in the editor of a book. Also participated in the China-U.S. exchange. Also, she went to the U.S. in celebration of the 70th anniversary of the war against fascism. As a thinker, she has climbed the Kunlun mountain for over 30 times. Let's give her a warm round of applause. Let's give her a very key question facing climate change in terms of technology policy and approaches. Could you give us some constructive ideas? It's a very big topic. I'm very delighted to come back to Shanghai, come back to Pujiang Forum to talk about water, a very serious topic. What have I been doing over the years? I've been thinking about this. And I've been doing and thinking. And while I'm thinking, I'm also acting. I was born near the Taiping Lake of Huangshan Mountain in Anhui Province. Taiping Lake, what is its relationship with the Pacific Ocean? It's a very big question. I spent 7 years at East China Normal University. I studied the history of the communist move and also the relationship between the Soviet Union and Eastern European countries. In 1988, I wrote a paper on that topic about nuclear weapons. Now, humanity is developing enough to destroy itself, so what should we do? With nuclear weapons and with extreme opposition, where are we headed? I wrote that paper. After writing that, I felt things were hopeless, so I went to work I went to the National Library. At that time, I wrote a project on the new cultural movement. I reviewed the history of the figures from that period of time. So I think we shouldn't stay away from this historical period. The new cultural movement raised the concept of science and democracy in China. The deeper issue is that in China, abroad, as we are moving into the future, as we are at this crossroads, which word can describe this intersection? So to be or not to be, it's a question. It's a Chinese character, Huo. It consists of water and tongue. So this is how this Chinese character is written. So to find the water over the past decade, I first went to Sri Lanka abroad. I went there to think. Sri Lanka is like a jewel on the oceans, but why are they facing so many disasters? They have tsunamis. From the east coast to the west coast of the US, from Seattle to Las Vegas, from Colorado. I was traveling and I was thinking, what kind of solutions can they provide? I also went to the mountains in Greece to there. I was also thinking. So that was the source of science. What did they provide to us? I also went to a water institute of the UN. On that wall, I saw a world map consisting of a water drop. This is like a water drop of hope. I also went to the headquarters of the European Union. I saw 28 flags, and I was thinking about how a disintegrated Europe could be unified. I was traveling and I was thinking. I also went to Kunlun Mountain. I climbed the mountain 30 times. I went to the Mingya Lake. It's like the Chinese Pompeii. I went to the Shahu Lake on Pamir. I also went to Qinghai Lake. I went to these lakes like Dongting Lake, Tai Lake. There was one day I traveled from Dongtinghu to Poyanghu to Fudi to Taimu Mountain. Despite the typhoons, I studied these lakes and their relationship with the typhoon, the rivers. In my traveling and in my thinking, just like what she said, we need to think bigger. So I want to share with you my ideas. Tu Rijing is the who participated in some archaeology discoveries in Beijing. He wrote a book called The Phenomena of People. He came to two conclusions. People are a geological phenomenon. He said that at the beginning of this world, through many years of discovery and utilization of research of the resources, we are entering a new geological era. Some of the farmers had to leave their original homes, and we saw a lot of mice jumping into the seas. And in Jilin, foxes couldn't stay in forests. They had to leave. So these are all problems. So in this new geological era, our question for the future is to think who we are in this world. UNESCO thinks that humanity should think about ourselves in the 21st century. This is something from Athens. So if you have found yourself, what should you do? This is not the ultimate purpose. The conclusion may be found from Confucius over 2,000 years ago. So I traveled to Qufu many times. Also, I went to the JFK Museum. I also saw the 4 pillars of the US, and I saw one of them is Confucius. I think the US thinks that Confucius is one of the founding ideas of the United States. In Qufu, I saw a plaque that says we should understand the relations of everything in this world. People should find themselves. People should reinvent themselves. So this is what I've learned from UNESCO. A British historian, philosopher, Toynbee Russell said, if this civilization cannot rise in the future, this will be very sad for humanity. We need to have a different understanding of this. Humanity have expectations for this civilization. So are we ready for that? Kissinger said something else. He said that we're a civilization disguised as a country. So civilizations belong to all, but we're now taking it as our own. This is another expectation. U.S. economist, one U.S. economist at his 101st anniversary said 2 things I want to share with the second thing he said. He said, stronger for China, stronger for the world. This is their expectation. This is their expectations. And David Griffin, in his book, said that people face a lot of disasters because we have neglected the existence of the universe. Human rationality is like a pair of scissors. They have cut a lot of natural bonds. This is a postmodern scientist. Another person wrote a book called An Ode to Cells, Thomas Lewis. He studied the Earth and the cells. He said that the Earth is just one cell, and the key part of the cell is water. So people study stem cells. The mother of stem cells is water. So we think the greatest kindness is water. Water is boundless. In one drop of water, we have 100,000 lives. So the heaven and earth have the same roots. So why do people have expectations for us? Because we want to inherit what is the past, and we want to create a harmonious future. From Yi'an to Huanghe, this is written on the tomb of Zhang Zai. Now I understand that from Taiping Lake to the Pacific, what we should do. I want to say one thing. I was born the year of the tiger. Water is the source of life. Blood is thicker than water. So they are connected together. Water is on its way. Let's take action to fight against disasters.
Thank you, Professor Hu Yanhua, for the sharing. We have 2 more minutes left. We would like to see if we have any questions here in the audience for our panelists. Please feel free to raise your question to our panel. Well, I think we had a very successful roundtable discussion today. Water technology is coming into the Oriental Pole of China. When we launch this project here, I think I would like to offer a little suggestion. Shanghai is home to Northeast North China University. This will be a hub for technology research. This will be the place where the technology is going to shine throughout the world. The Huangpu River is going to be a role model for water research. Qingpu is one of the districts in Shanghai where the Dianshan Lake is located. Water and the mountain can reinforce each other. Water technology is going to take deep roots here in Shanghai. With its strong universities and colleges, we believe we will be able to build alliance and partnerships with those around the world to share our research outcome. It's also going to be a platform for innovation. Yixing is near the Taihu Lake. It is a good place for the commercialization of technology to turn water into resources. Also today, we witnessed the signing ceremony of the Yixing It's a very good coincidence. It is in the Anji County of Huzhou City in Zhejiang Province where President Xi said the very famous line that green mountains and clean water are gold and silver. It is also important that we build educational platforms. Hangzhou, the city of Hangzhou, is known for its West Lake. It's, I think, the highest form of the beauty of water. In North China, all of these cities are in south, whereas in North China, in the Chicheng city of Hebei province, there is very rich reserve of iron. There, it is also a place good for water-related technology research. And also in the Aksu County of the Xinjiang Autonomous Region, there is a very famous river known as the Duolang River. It is very well known for its tides and waves. Can be known as the Danube River in China. And also the city of Tianjin, there is a place known as the Minghe River. So these cities are very special. They have this very special connection with water. They are good places for different aspects of water-related research and science. Thank you. I think our discussion culminates at this point. Let us thank our panelists for their great input. Let us give a big hand to you all. Thank you. Let's give the microphone back to our moderator. The organizer has invited Madam Hu Yanhua because they know she has great knowledge on water. And they've also carefully selected the moderator for the forum. I would like to introduce myself. My surname is Hong, which has a water. So in my name, there's full of water. I was also born around the Dianshan Lake in Shanghai. I think this is carefully selected by the host. We all have a very special connection with water, and we host this forum together with the Netherlands. We know that about 1/5 of the land of the Netherlands is reclaimed from the sea. So it is a country with very rich experience in water technology. So I appreciate the organizer for finding these people, these countries which are deeply connected with water, and also the speakers and the moderators. Last but not least, I would like to invite a representative from the Science and Technology Office of the Netherlands, Ms. Willande Lee, to give some closing remarks.
Ladies and gentlemen, good morning to the Dutch audience and good afternoon to the Chinese audience. My name is Willande Lee and I'm an officer for innovation, science and technologies at the Netherlands Innovation Network in China, one of the co-organizers of today's event. So the Netherlands Innovation Network is part of the Ministry of Economic Affairs of the Netherlands, aimed at supporting and stimulating knowledge-intensive collaboration between China and the Netherlands. As a network, we look at opportunities for economic, scientific, and R&D cooperation. If you need support in connecting to Chinese or Dutch partners, please do not hesitate to contact us. So the roundtable marks the end of today's forum about water technology. Thank you to the speakers for sharing your expertise and ideas, and thank you to the panelists for the fruitful discussion. We hope that you now have a better idea of Sino-Dutch collaboration. So thank you all for joining this forum.
大家都上来拍个合影照啊。